Good morning, everyone. Good morning. Welcome you all for the pre-summit. So, this is a part of India AI Summit 2026. So, I would request Shravan sir to speak about app care and his research area and what are the things that we are doing in the app care.
You, Srinivas. Let me share my screen. Uh, I hope my slides are visible. Can someone please confirm?
Yes, sir.
Yeah, okay, great. So AppCare is a part of CSIS. I mean, so there are most of the faculty, who are part of AppCare are from CSIS. It's not technically a strict superset, but uh, most of them are from CS. So this is a lab where we do machine learning mostly. Let me just go to the next slide. So what's different here from the usual ML labs is we don't try to throw more hardware at every problem. So one of the major concerns in the current community is ML community is that people are using inefficient algorithms in the sense that I mean any new problem mostly people try to add more data and so on. So can we do something more efficiently? So this is our main philosophy. So the screenshots that you see on the slide are from one of the recent articles, so where we use the the age-old idea of Radon-Nikodym theorem, so where we pose the anomaly detection problem as a distribution shift and then use the Radon-Nikodym derivative to correct for it. So this is one such work. I mean, we do also do a lot of other works which are mostly theoretically grounded, taking ideas from various places such as economics, pure maths, and so on, and physics, etc. Right. So here are a couple of more recent developments that we have been doing. So one is, so we have developed the idea of what's known as a quantile activation. So we have actually shown that it outperforms Meta's Dino V2 model, which is supposed to be a very large model. So we are also working on small language models for various applications, starting from it could be from reactors to Cosmos and so on. So we do also have an elite uh, collaboration. I mean, collaboration with elite institutes. So some of them you can see on the right hand bottom, right? So we're working with people from IIT Kharagpur, IISc, Caltech, and so on. Right. So more on these technical aspects would be covered by my colleague later today. Right. So yeah, so I'll probably skip this slide. I mean, let me just go back to this. Yeah. So here is another development where we, try to use what's known as adapt framework to, model languages with, for safety and so on. Okay, I won't go into the details of these. So let me just give a, uh, high level view. So this is another work where we show that for routing we can reduce the distance travel by about from 44% to 53%. So this is another work which is based out of theoretically grounded techniques for last mile delivery. Right. There are more areas which we work on. So this is for social good. How do we do autonomous mobility? This is another work which is in collaboration with somebody from the US, right? So overall, we have about 12 core AI faculty who work in the theoretical areas, and then we have 51 members, coming from across departments, mostly working in cross domain. And within 5 years, we could manage to publish in a lot of good journals and conferences. Some of the names you can see here on top, such as JMLR, TMLR, NeurIPS, and so on. So our focus is very clear. So we want to develop white box models which are efficient and interpretable, and this is the main focus. So we also have a lot of grants and so on, which I didn't mention on the slides, right? So that's about it. I think I'm out of time. So yeah, so one last thing I'd like to mention. So BITS Pilani is the first private institution to climb into CS rankings. So CS rankings is based out of what kind of publications, what kind of venues do a particular institute publish in. So based out of that, so we are currently ranked 8 on the CS rankings list, one of the very few private institutes. I think I'm out of time. Thank you.
Thank you, Professor Shravan. If you have any questions, you can just raise your hand. Yeah, I think there is no questions, and we'll proceed with our next talk by Professor Amitava Das from BITS Goa. Sir, can you unmute yourself?
My screen is visible?
Yes, sir.
And I have 15 minutes time, right?
Yes, yes, sir.
Okay, so let me get started. I joined BITSCO around 5 months back. So I'll be touching 2 research problem, my lab, which I call Pragya Lab, we have been dealing with. One is dense world and one is AI Constitution of India. Obviously, time is short. I will not be able to go into the details of nuts and bolts, what exactly we are doing, techniques and so on. But I will kind of hover through what exactly we are doing. So the first problem is world model. I believe with the success of large language model and its effect on the AI overall, everybody is excited. We are living in the AI world. Next inevitable model is world model. All the stalwarts, starting from LeCun to Hinton to Fairfairly, everybody is talking about it. This is the next big thing. So we have been talking about dense world. So model or world model developed for the Western countries where traffics are really in order, everything is good, does not work in the situation where world is chaotic, dense, populous, and so on. So this is the problem we call dense world model. So we have been developing that heavily. We have a lot of data. And the second problem is AI Constitution of India. India is definitely a country of several religion, several castes, language, and so on. So the question is how AI is biased or unbiased towards this all religion, caste, and so on, and how AI should not harm the societal balance we have. So I'll try to touch both of them very quickly. And we have a lot of collaboration, obviously, with a lot of industry and lab across. So when we talk about global south, we talk about so many countries, like from the line we draw in the middle of the world. So I believe there's 27 to 30 countries which have similar characteristics. It's very dense, population, mixed traffic, informal right to a negotiation, extreme lighting condition, weather, and so on and so forth. So that's the dense world problem. So first, let us understand what is the world model. So I believe it started long back, 1940s, but with the recent success of Jan LeCun JEPA, Joint Embedding Prediction Architecture. Let's say we have a video of this kind, and we patch specific section of the video and we try to. Unlike the large language model where we actually predict the next word, here we are trying to predict the next world. So next actions and sequence. So if we can solve this problem, we can solve the robotics and many other things, which the next inevitable milestone for the AI. So for example, we bought robot and so on. So when we start doing the simulation, we make the robot to work in Indian urban scenario. It cannot, because it's really chaotic. So to actually understand the scene, so it has to understand, let's say, given this person, in the next scene on the time step, it will actually go straight, not go straight, accelerate, slow down, jump into left, right, whatever. So the world model has to understand this, and if the world model understands this, then the robot navigation or any other things could be very easily be done. So looking at, so we break down this problem. World model is a very new idea. I believe there are 4 or 5 papers only altogether in the scale. So we break it down into 3 factors we call layout, agents, and interaction, because if we have to do the dense world problem, we cannot learn everything together. So we are bringing the idea of factor JPA, and we have collected so much video. Part of the video collected by students, part of the video we have collected from open source YouTube, and part of the data is collected from one of the agency we are actually collaborating with. So we have more than 1,000 hours of video. So starting from the tier 1 cities, tier 2 cities, and around 50 plus monuments in India. And we have several kinds of video. We have drive-through video, we have walk-through video, we have drone video, we have video in the night, morning, in the extreme weather condition, this and that. So it's a very large data set. So this is some kind of snapshots of the data sets we have collected so far, and so on. It's going on. And with that, the monuments data and etc., we are applying the Gaussian splatting to create the 3D map of those monuments. Probably you know all this technique, which is becoming very popular in recent times. And this is some of the examples we have. For example, this is very good 3D map we created for India Gate, Qutub Minar. This is Nahargarh Fort. This is Victoria Memorial, Jal Mahal, Charminar, Lotus Temple, etc. So with this, we are developing this world model. We call it Factor JPA. So this is we are developing, and hopefully we'll soon we'll be able to release this. So as I said, that we break it down into 3 problems: interaction, agent, and layout, and that's called factor. Factor is basically the matrix factorization technique here, what we developed in-house. So if you look at the left side, this is typically a foundation model. It has 30 plus stack layers. And what we are trying to do in the right side, if you see in the x-axis is the layers, from 0 to 40. And we are actually trying to create separate channel for learning the layout, the agent, and agentic interaction, which is actually getting converged at the last layers. So this way, the learning is getting separated, but also getting efficient learning. And we are applying actually Kronecker factor and little kind of improvised version of that, which we developed. I mean, I don't have time to go for the mathematics and so on. I'll skip this part. More on with the transformer has several limitation of losing information throughout the 30 lakhs 30 stack of layers. So we are developing an updated version of transformer, which we call graviton, inspired from the quantum physics. So we taken the idea of graviton there. Again, I will not be able to go into the details of nuts and bolts here. So the idea is, in a larger stack of models, we tend to lose information. So how we can retain the information? And again, I'm skipping some of the slides. So we have created some gated entities, which is making sure, using the spin to architecture of quantum physics, and we are making sure that in the long range understanding, those spin to actually making sure that the quantum mass is getting transported throughout the layers is getting, not getting lost, the information. And we are able to learn much more information using smaller amount of data, which is a limitation of today's transformer. It's a data hungry, method. So with that, let me move on. So the question is, okay, fine, all this fancy math and models and etc. So what is the output of this? So this is my vision. Let's say in 4 years, we want to train our own robots, and we want to create a Indian Army regiment. I call it Haldi Ghati Regiment, and I want them. And this is my dream. I want them to parade on the 26th in the Rajpath. So we already bought robots. I believe they will come soon by this month, and we have been developing this. And first, we want to create a set of guard robot which will guard these monuments. Now, to train our robots for the guarding, we can never get attack situation. So what we are doing with using those 3D models, we are actually throwing a lot of motion GPT, humanoid on the 3D scene, and actually creating synthetic episode of those attacks and training our robots. This is the simulation. Okay, with this, let me move to the next part of the story. I call it AI Constitution of India. Instead of showing, instead of talking, let me show directly. So this is something we have been doing for more than 2 years now. So there are many models, available today, and India is a mosaic of several religion, caste, and so on. So we picked up 6 major religion, and the question we keep asking is how biased the available models are in terms of this religion, and then the division of yeah. So for each religion, we have broken it down to several castes, and this is a list we have taken from the central website or the census website. So 70 Hindu caste, 27 Muslim caste, 16 Buddhist caste, 13 Jain, and 11 Sikh. So we have evaluated, heavily on all the available models, and this is an ongoing task, English models and let's say Indic models and so on. So let's say if we go to GPT 4.0, obviously this is a wiki page, it will be loaded, and we see that how biased this is towards that particular religion and caste. So we did it for multilingual setting, English and other languages and so on. So very exhaustive list. I believe this is very well covered by MIT Technology Review, European Commission yearly review, and so on and so forth. So we developed an architecture or debiasing technique we call Ambedkar. Obviously, it's a tribute to him. So which actually look at the token distribution at the deployment, and then try to debias at the runtime. And this plugin could be used on the GPT as well. It's pluggable. So that's one of our development. Now I will end with this part of the story. We know that everybody is talking about agents. So which is good. According to some prediction, in another 2-3 years, there will be around more than 50% cases we'll be seeing agents. So that means 50% decision of the society will be taken by these agents. Now we know all these, LLMs or AI has biases, and we simulate it. Let's say we plug in agentic system into banking, into judiciary, into healthcare, into education. All these biases will be actually then translating to the downstream system. So here you see a simulation of judiciary system, and you see with the name. I mean, I keep telling this line again and again. One of my favorite movie, Wednesday. It says that log aksar naam mein mazhab dhund lete hain, and that is so true for the AI as well. And you see with the with the religion, you see the bail is denied. So how to make sure, and we did this several times. Right side, you see Monte Carlo simulation of 10,000 times, and we see the biases still exist. So what we are developing, we call it agentic operating system, Agent OS. So we are developing game theoretic based equilibrium, Nash equilibrium, and we are trying to make sure that when this agentic system being deployed, they are out of bias. So with that, I pause and open for question.
Is there any questions?
Yeah, Amitabh, this is Navneet here.
Hi, Navneet.
Yeah, hi. So just so you mentioned about the different kinds of cultures and the Constitution of India, and so what kind of work are you also doing? Some culturally aware kind of work?
Yes.
Okay.
So there's a famous model from sociological SWOT model,
Mm-hmm.
which breaks down culture into 10 dimensions.
Mm-hmm.
So I believe I did a lot of work on this. I could have shown you, but time is limited here. But we can obviously connect offline.
Yeah.
So we break down culture into those 10 dimensions, and we wanted to understand India possesses what kind of culture. It's a
Mm-hmm.
combination of traditionalism, hedonism,
Mm-hmm.
universalism, all those things. So yeah, we can definitely talk about this.
Sure, sure, sure. Because we are doing something on similar lines, like generating videos and images which are culturally aware in the Indian context. So, yeah,
Sure.
yeah, sure. Thank you.
Thank you.
Professor Arvind has some questions.
Yeah. Please go on.
Uh,
Arvind is
uh,
once you discover biases in models towards religion, what is the next step? So okay, so two part story. One is we can debias the model, or we can create some kind of guardrail system which can actually do this unbiasing. The second seems to be more feasible because this model unbiasing, etc., again very costly because they come from data, and from where it comes, it's a big question. So we are doing the second. We are creating system which makes sure that in the deployment, biases are not there. So as I said, we are trying to create agentic ways. We call it Ether. So which makes sure that in the deployment, those agents are not you know translating those biases into the downstream task.
Is
So we
that
can
through prompt engineering, or are there other methods to
no no no
detect
absolutely not
biases? Yes.
prompt engineering. I can go on and talk more about
Professor
so
Amitabh Das, like we have a shortage of the time.
yeah. So we can connect offline. So these are not definitely not prompt engineering. Yeah, over to you, Srinivas.
Yes. Thank you, Professor Amitabh Das. Our next talk will be by Professor Shantanu Sarkar. He is a senior faculty from BITS Goa, and his talk title is AI and Transportation. Over to you, sir.
Hello, can you hear me?
Yes, sir.
Okay, so let me share my screen. Okay. I don't know if you can see my screen.
No, sir.
Okay. Mm. Can you see?
Yes, sir. We can see a blank background.
Okay.
Yes. We
Can
can
you
see.
tell me what I see?
We can see the presentation, Department of
Present.
Computer Science and
Okay, all
Information.
right. So yeah, so I will briefly talk about our work that we are doing here in terms of I would say smart mobility, and we'll talk about two ideas. They are actually work in progress, and there are a few which have already been published. So I'll basically cover all of them briefly. So first one is the idea is called altruistic ride sharing. Basically, that idea is more of a community-driven approach to short distance mobility. This idea. So I'll tell you the problem that that we try to address. It's a completely new concept, which is which we call it as community-driven ride sharing, where if you look at the traditional ride sharing, that is second. Yeah. So if you look at the traditional ride sharing, that's more of Ola and Uber kind of a model. And that basically, as you know, that creates kind of a price war and customer churn. And in parallel, we also see that people are in general leaning towards more of ride sharing rather than owning a car. And so when people are actually willing to do ride sharing, and then a traditional ride sharing which is driven by money, and then where there are drivers and riders, there are price wars, and there are any other kind of issues. Mostly sometimes it could be even trust. So here, what we propose here is that it's a zero cost service where there are no payment fees. But what's happening here is that people are actually, when they're sharing, when they're offering the ride to other people, they're earning some points, and then when they can use those points to get a share, kind of ride share. So the idea is like this, that so here, this project basically kind of introduces a new type of ride sharing called altruistic ride sharing. Here, the core concept is basically a dynamic peer-to-peer transportation system, where basically where all the participants they have their own vehicles, and which they can interchangeably assume the role of either driver or rider. There seems to be a problem. Can you hear me?
Yes, sir, we can hear you.
Okay, I got some notification. So okay, so here we yeah. So essentially, they they can interchangeably use their car, and they can, somebody can be a driver today, can be a rider tomorrow. And there is something called altruism engine. That engine is basically built on a social currency that's called altruism points. And as a driver, you can actually earn the altruism points, and by giving rides. And as a rider, you spend your points to get a ride. Um, so this is basically a functional medium of exchange, and the money is replaced with this kind of points. Interesting point to note here is that these so-called currency, which is altruism currency, that is generated and used within this system, within this closed loop system. So this currency does not exist outside. Money cannot buy these altruism points as of now. So in order to really model, so what we have modeled here is that we model the social dynamics. The system is using a birth and death model, where agents can join or agent can drop out the system. And agents' a decision to drop out is again influenced by the algorithm score. The agents with a lower score, they may want to leave. And optimization is more of a cooperative AI learning. Here, the goal is to optimize a system-wide objective, such as minimizing the total community cost, detours, and wait times. So essentially, here, right now, what we are doing is that we are using an agent-based system, an agent-based model, a reinforcement learning model, where these agents who are essentially drivers or riders. Here, the way it works is as follows: when a driver gets a request for a rider, and driver is going from point A to point B, and when the driver gets a request to pick up a rider, the driver may want to take a detour and pick up the rider, but that detour and by picking up a rider, of course, it gains a point, but by using a detour, it also kind of gets a negative point because it is not taking the optimal route. So there is a kind of a trade-off between how much of a detour a driver should take to pick up a rider. And so we have built the model and tested that using a simulation framework. We have taken the New York taxi and limousine commission data to actually do this simulation. And we actually wanted to observe that by using this model, various metrics like carbon emission, then amount of congestion, and the amount of vehicles that are there on the road, to what extent they are optimized. And so here our simulation results basically show that here if you look at this grid X, which is green bar dots, that basically shows that there is a traffic density reduction. Remember that the way we are simulating is that we are using a set of random agents, and then they have some source and destinations that are picked up at the beginning of the simulation, and they alternately choose the role of driver and rider. So here we actually want to also check from economics perspective to what extent such approach gives a benefit. So we have done initial testing, which is using the Lorentz curve, which basically tells the line of equality, where on one hand they're giving some they're offering some service and what benefit that they're getting in a cumulative sense for the entire population, and the straight line basically means that that's a line of equality. They get what they offer, and the blue line below, that means that right now, I mean, of course, eventually they'll get they'll reach the line of equality, but they end up giving slightly more than what they're getting. But that's generally the case for any social system. And our objective is to basically have this green line, the blue line, as close to the this like diagonal line. So essentially there are so while this is a work in progress, there are a few interesting offshoots of this idea. One could be carbon credit pooling, that where the community members can collectively earn and trade their carbon credits based on the algorithm score. We could actually use something called this idea can also be used what is called reverse logistics, where there are logistics companies who actually use their trucks to move items from one place to another, but when they come back empty, and they can actually be altruistic there and then offer services while coming back to their destination point, their source point actually from the destination. If we look at the EV specific altruistic features, there could be we could extend ideas to community battery network, altruistic charging ideas, and grid to community, etc. Those are kind of future ideas that could be explored. Again, however, that's based on our current work, and then to what extent we are successful in actually having this stable model. I will switch to another topic, which is so Srinivas, how much time do I have? I guess I have.
Yeah, it is almost done.
It's just spent 10 minutes. Yeah, so I have 5 more minutes.
Hmm.
So I'll introduce another idea, which is called adapt. Adapt is basically how do we detect the anomalous driving behavior of a driver. And so, of course, this has a very strong market potential. The idea here is that we are going to collect the driver behavior from various sensors. And here, the idea is to identify the driving behavior using multiple sensor modalities. So at the core, it treats this driving like a language, where these kinematics are actually tokenized into kind of discrete driving primitives. And essentially, it uses this structure representation to detect the deviation. So in a sense that when it is treated like a language model, where then these kinematics are tokenized, and it actually predicts the next token, which is a good token, and it compares the good token with the bad one, which is the actual one, to see to what extent it is deviating from the good token. So there are 3 main inputs: the past kinematics, multi-view RGB images, and LiDAR point clouds. So the kinematic data is basically like position and velocity that is fed into the like vector quantized VAE model that actually tokenize the continuous motion data, and it creates a discrete vocabulary items from there. And RGB camera feeds are actually encoded into bird's eye view features to align them to with the vehicle's spatial coordinate systems, plus the LiDAR data. And these are fusioned via the cross attention bottleneck layer that we are actually building. And we basically create what is called a sort of weighted attention bottleneck model. Then once we build that, we have the system which can basically predict the next good token. And now we have this divergence calculation, that we have the actual token which is coming from the actual driving. And then we now compare the good token with the bad token to basically quantify to what extent the driver is good or being unruly. So that's what we call it as our adapt framework. Once again, that's a work in progress. So what I've told you is the idea. And if once we build it, so the way we are building it is this, that we are actually again using the help of simulation in NVIDIA Scala simulator to actually simulate a lot of good driving behaviors, and creating a data set of good driving data set using which we actually train the model. And then we ingest what is called our ego vehicle, which is our where we inject some sort of unruliness, and then check to what extent our model is able to detect this unruliness. That's the idea. And of course, it has its own usage, where there could be such kind of things can be deployed on OEMs. The vehicle manufacturers can actually use this and then add that as a part of their offering. It could actually enhance V2X connected infrastructure for real-time unruliness score sharing between connected cars. It could be even connected to police and insurance policies, vehicle city planners, to basically in real time detect to what extent it is to what extent a given dynamic city condition is ruly or unruly. That's the future of it. But again, as I said, this is a work in progress, so we are actually working on this idea. I will also talk about the few things that we have done in the past, which we have published in attribute transactions on intelligent transportation system. What is the one is the AI-driven last mile path sharing for food deliveries, where the idea is that you are at the last mile. How do you basically check that you know, supposing we actually have the shared vehicle, and this can be actually used for Ola and Uber, where we could essentially and assuming that these vehicles are actually providing food deliveries, how they can share, they can group, even kind of cluster a set of requests together so as to minimize the total number of hops and total the fleets. That's one. And the other one is again very similar to our altruistic share, but here again it's based on Ola and Uber kind of model, where the drivers remains drivers, and riders remains riders, and there is no altruistic currency but real currency here. But here it is cooperative in a sense that we actually showed that sometimes too much of detour is not actually a good idea. Sometimes rejecting a rider request is actually okay. And that is more beneficial than actually doing too much of a detour. And sometimes that can also cause more congestion. So those are kind of non-trivial outcomes that were found in this research, and both of them were published in Attribute Transactions on Intelligent Transportation System. So this basically gives a very brief overview of what we are working on and what is our current status. Thank you, and I'm open for the question.
Thank you, Professor Shantanu. So we'll go with the next industry talk by Jyotirmoy from Wipro Research.
Thanks, Srinivas. Can you hear me?
Yes, sir.
All right. Let me share my presentation. So it's 10:45. I'll take 10 minutes to
Yes.
do my part. Yeah. I hope the screen is visible.
Yes.
Okay. All right. So good morning, everyone. My name is Jyotirmoy, and I head the Wipro Research Division. And I'll talk a little bit about first the background about what we do, and then I'll actually give you a research portfolio overview of what all projects we have that align to machine learning, AI, and some other little more advanced bets that we are taking in this field. So first, to set the context, Wipro is known for its IT services, and it's a large software technologies company. While that is well known, I'm not a part of that organization. Wipro also is heavily into manufacturing, and I think most of you will know the popular products that Wipro makes, which are the personal care and consumer care goods like Santur and Yardley and Wipro lights, Wipro bulbs, those kind of things. So that's one part of the manufacturing arm of Wipro, which is this CCLG group that is shown here. And there is another division of Wipro called Wipro Infrastructure Engineering, WIN, which is heavily focused on large scale manufacturing operations, right? So we have 6 business divisions. So, for example, we have hydraulics as a business, and we that Wipro is the world's largest hydraulic cylinder manufacturing company, and supplies to every major equipment manufacturer that we see. So, for example, every JCB that we see on the road in India will be fitted with a set of hydraulic cylinders that come almost 100% from Wipro's factories. Similarly, we have a very large automation business which is into robotics and large scale system integration, turnkey system integration. So any say, for example, major say battery line or engine line of a new car that is getting launched, that entire automated line with all the robots and the programming and the flow control and all of that is designed and then manufactured in our factories. this again, it's this division is a global division. So while headquarters is based out of Bangalore in India, we have factories in Europe, US, South America, Southeast Asia, all across the world. Aerospace supplies landing gear actuators, structural parts to Boeing and Airbus. 3D is a business division that focuses solely on 3D printing. Water is a business division that focuses on designing and then installing and commissioning effluent treatment plants, wastewater treatment plants. And then finally, we have the latest business that Wipro has ventured into, which is called electronic materials, which is into the manufacturing of semiconductors and electronic materials for PCB assembly and all that. So now Wipro Research, the organization that I lead, acts as a horizontal to these 6 businesses that I just mentioned, and takes up these strategic little medium to long term bets that we need to develop, potentially IP in house, so that in this age of AI, the manufacturing sector also stays relevant. So um, with that background, this what we have done is with BITS Pilani, we have a very strategic partnership where we sponsored the Wipro Win Fellowship. And the intention of this fellowship is twofold. One is obviously to enable this advanced research at a doctoral level and make sure that we are funding the right professors, research groups, as well as the students, but also to incentivize the PhD program in general, and then make sure that students who are receiving this fellowship have an opportunity to join Wipro Research post their thesis and defense, and then have a career within Wipro Research as staff scientists. So, and at a very competitive environment. So that's the intention of our organization. So we currently have about 20 active projects that are under sponsorship. Some of them touch upon AI in a bit. So I'll talk about those very briefly. And then please feel free to connect with me for any more details about any project later. So I think I can divide these projects into 5 broad categories, right? So one of them focuses on since Wipro is heavily into robotics and automation, we really want to get into how do we leverage simulation to reality transfer for generalist robot control, and not just individual robot control, but controlling large scale systems and factories that contain multiple such agents in the physical world. So that's one area of research. Second one is definitely in computer vision. We have a big group of students and professors working on certain applications focused on the manufacturing side to develop our own foundation models for multi-camera view synthesis. We have a large group that's focused on the neuromorphic computing and how do we deploy AI at the edge. So we have say multiple sensors that are getting developed now for detecting touch, pressures, humidity, and all of those for robotic grippers. And then we also need to look at neuromorphic computing and how, what kind of fundamental research we can do around that. There is a bucket around generally manufacturing intelligence and how do we make digital twins of the manufacturing processes. How do we start doing anomaly detection, predictive analytics? How do we start eliminating expensive sensors from the system so that we can start estimating their state? And the final bucket is around generally AI systems, right? So we see a proliferation of models that can say claim to have SOTA performance in the academic or controlled environments, but when we have to look at industrial deployments with certain safety guarantees, there are certain system level researches also that we're looking at for mobile robot navigation. So double clicking on each of these, the vision language action models and foundation models for robotics, we are trying to actually sponsor some research around how do we model these VLMs or VLA models so that they are actually able to tokenize and then directly output low level robot actions. And this is centered around industrial robots. So while it is easy to I would not say easy, but it has been established that we can control lightweight collaborative robots, we still haven't seen a lot of work happening around high speed, high precision industrial robots where these generalist policies have to be generated and then in real time connected along with feedback to the robot. So we are evaluating all the available models, as well as trying to figure out how to develop our own VLA models around this. The second part of this research, which is around system level coordination, where we have, say, a large factory, and the factory, so currently factory is coordinated using very brittle handwritten rules that determine which part goes to which machine at what point of time, depending on the routing. We are trying to actually figure out how do we scale up large scale simulation of such systems, and then learn policies that can actually, that are not brittle and that can react to changing input and output characteristics of that factory. So depending on what rate, say, input material is coming in or output demand fluctuates, the robots will realign, and then processes are reassigned to make sure that the throughput of these factories are maximized. So that's another interesting area of research that we're looking at working. In computer vision, I think the bet that we're taking is that we will start seeing a lot of edge deployed, very niche focused computer vision models for very specific applications in the factories. But if we have to actually achieve generalized vision, so video camera deployment and then vision analysis in real time, we will have to actually deploy multiple cameras that are looking at the same scenario, and then they are able to bypass the issues of lighting and occlusion and the issues that we will typically see during a practical deployment. So developing this foundational models for multi-view geometry, and then figuring out how do we, say, extract 3D optical flows or scene flows, and then convert them into actionable tokens for individual robots or conveyors or whatever manually driven forklifts. So that is something that we are looking at, and not just control, right? So we can also use this kind of deployments for analyzing the motion of, say, certain manual objects, or for inspecting the quality of or the process steps of a manufacturing environment, which typically until now had been in the purview of a human supervisor or line manager in the manufacturing factory. So that's one area. The other area, which is also very interesting, and we expect to see a lot of progress and work happening in this field, is currently the industry 4.0 stories that are told in the industry, where they look at deploying sensors and IoT and looking at predictive analytics. They all get stuck at a single stage, which is data collection and ingestion, right? And because of the breadth and the variety of machines that we see in the real world that are deployed and at different levels of maturity in terms of what sensors are available, what network is available, what kind of working environment do they operate in, it becomes typically a showstopper. And industry 4.0 projects do not go beyond a pilot stage. So we are looking at actually how do we bypass that problem, and then look at, again, computer vision models that use, say, cameras deployed around this machine to figure out, can we measure the cycle time of the machines that are working in that factory, and look at anomaly detection, look at machine state classification, and start measuring actually the equipment efficiencies without touching the actual logic controller of the machine. So that's another area. Neuromorphic computing is a very different field. Again, it has less of AI research right now going on, but more of, I think, the material science and the electrical characterization of the materials that we're looking at for developing these neuromorphic memristors that can eventually be deployed as AI inference nodes at the edge. And the belief that we have, it's a research bet that we're taking. We are yet to see commercialized impact, is that we will start seeing very large scale sensors getting multiplexed and then interfacing with these edge AI inference nodes, and they're able to actually process data at a much more granular scale for AI models, higher level AI models, to process and then control. And so typically the applications are around skin like sensors, where the grippers that go with the robots, the hand effectively or the end effector, will have multimodal sensing. They will be able to sense touch, force, shear, temperature, humidity. And we need a way to actually gather all of this data and then process this at the edge without overloading the power requirements of the system or the network requirements of the system. And one specific application that we actually have a live sponsor within Wipro working on this is how do we start measuring surface finish on different industrial finished surfaces, and this could be like metal surfaces, this could be semiconductor wafers, but the fact that there is a sense of contact uh, contact sensing, and then figuring out how do we extract information to measure the surface finish is something that's an open problem that we intend to solve using this neuromorphic system approach. For manufacturing systems at scale, we have definitely some projects that are ongoing with related to physics informed digital twins, and how we can start looking at collecting, say, sparse data from sensors at different points of the processes within, say, our water treatment plants or different other processes that we will expand to slowly, and then from that create say a model of or a neural network that can embed the physics of that process, and then continuously update its own intrinsic knowledge as well from the real-time data that is coming in from the sensors. And the idea is that we use these models then for eventually anomaly detection, for predicting future scenarios where, say, the input parameters or the output requirements are going to be changing in real time, and then we start deploying these as operate tools that are used for operations of these large plants or industrial, say, effluent treatment plants and water treatment plants in real time. So the idea is to actually build some amount of trust in these digital twins as well, so that people can start moving into these systems and then using them. There's also some research that's ongoing around how do we start looking at eliminating sensors from certain complex systems. So, for example, our hydraulic cylinders that we deploy in the field, currently it is a very hard challenge to actually install a sensor in that harsh environment where these cylinders are working at around 400 bar and very high pressures and forces and loads and vibrations and all that. So we're looking at how do we actually start interfacing or interfacing, say, flow gauges and pressure valves outside those cylinders, and then start using that to estimate the state of a vehicle. So, for example, if a JCB is, say, doing a trenching or a digging operation, can we start without adding any additional sensor, can we start looking at estimating the state of that machine and then eventually loop that back as feedback to control that machine itself? So a fair amount of data driven optimization and learning the dynamics of that system will be required to achieve this. And yeah, finally, I think I also spoke about how do we look at system level research. So we have definitely an interest in deploying these AI models that are trained for, say, navigation and path planning and fleet management, for example, on our robots that go in, like, say, Wipro deploys, say, 500 to 1,000 robots a year. And we would definitely want to move to a stage where the AI models get deployed at the edge. But the research that then needs to be done is around how do we prove that the hardware and the software stack can be statistically guaranteed to not have any kind of say adverse output or a non-safe behavior that can result from the system. So we'll have to look at redundancy of the systems, we'll have to look at fail safes, recovery, those kind of things. Again, these are it's at a nascent stage. Yeah.
Sorry to interrupt you. That we have exceeded the time, so we can wrap up quickly.
Thanks. Yeah. So it's a nascent stage. So, but happy to collaborate and discuss any of these projects, right, with any of you going forward. So with that, I'll end. Thank you, everyone.
Thank you, Jyotirmoy sir. Is there any questions that we can quickly address? Yeah, thank you. So the next talk will be by Professor Prateek Narang. He's a professor from BITS Pilani campus.
Hello, good morning, everyone. I'm audible.
Yes, sir. Yes, sir. You're audible.
And my
Screen is
screen is
visible.
visible.
Yes, sir.
Great. Okay, I'll keep it short. I'll be talking about the work that we do here at Pilani in the Bird Eye AI Lab. This is a collaboration with a company called Bird Eye. The broad area which I'll be discussing today is essentially voice of customer analytics or test analytics moving beyond sentiment. So we call it actionable AI for prescriptive analytics. So it's essentially an applied work, a business facing work which targets the paradox which businesses face, that they are drowning in data but starving for insights. So essentially, every business which is a customer facing business is receiving thousands of customer reviews, thousands every month, maybe thousands every week. Amongst those reviews are some valuable insights, what you're saying about your business, which you should be able to harness. But finding those specific actionable items, that's the hard part of the story. So we'll be talking about two approaches that our team has been building in collaboration with Bird Eye to build a cost-effective AI pipeline that essentially is about taking this raw volume, lots of data, and turning it into immediate action. So yeah, that's the big problem broken down. Imagine an executive looking at thousands of customer reviews. Majority of them, 95% of them, are just going to be pure noise. People will be talking about, like, yeah, it was a great place, they had a great dinner, the food was nice, they got stuck in traffic. A lot of stories might be there. So the review volume is colossal, and that definitely a manual analysis is impossible over here. Amongst those colossal review volumes, there is a lot of unusable noise, but there is some important signal which a business should be looking for. Much of the incoming data is unusable to you, which is actually diluting the insights. However, hearing the customer is important for any business to be able to survive. Furthermore, just hearing the customer isn't sufficient. The business must be able to transform that feedback into a strategic advantage as well. That's where our focus is. So one thing is hearing out the customer. Hearing out the customer is perhaps not a new problem being targeted, but what to do? What's the next action you can take as a business to have a strategic advantage, let's say, against your competitors? So, as I said, it's not a very new area in itself. There are a number of legacy approaches out there. Every business these days would be having a dashboard, and that dashboard is telling you the sentiment, perhaps 38% negative, 45% positive. So that's great, but what more than that? So generic outputs are a problem with the traditional AI or NLP approaches, that they generate verbose, vague advices, like you improve your customer services and things like that. They don't tell you what exactly to fix. Because of the deluge of data out there, many older classifiers also suffer from a low recall problem, where the critical customer recommendations are like a needle in a haystack problem for them. And of course, we don't want to have very resource heavy deployments. Many legacy systems require high compute, because ultimately, as a business, every let's say GPU call or LLM call you make is costing you dollars. And keeping in mind the thousands of reviews a customer might be dealing with on a regular basis, yeah, you don't want to be resourcing. So essentially, the evolution of analytics as we see is moving beyond what happened. One area of analytics is descriptive analytics, which talks about the past. Traditional sentiment analysis, identifying a customer is happy, not happy, doesn't explain why, doesn't explain what to do next. Another approach of analytics is predictive analytics, forecasting trends. Okay, you had these many customers over the past week. How much footfall you can expect over the next week? How much footfall you can expect over the holiday season? That's predictive analytics. The evolution of analytics is moving towards prescriptive analytics, which is talking about action-based AI that can deliver personalized, actionable recommendations to improve decision making and drive operational growth. That's where we are focusing our attention. So we call the first approach as a review sense approach, which is essentially a recommendation generation engine. So the broad idea is fairly simple. You have lots and lots of review data coming from customers. You have to have a strategic filtering as a first step. Our engine rejects the reviews which are, just pure noise talking about the food was nice, the place was nice, we had a good time, 5-star ratings, don't have any for any value for the business. So perhaps you could just filter out the positive ones. This review sense as an engine focuses more on the negative reviews, and then uses context-aware intelligence, fine-tuned language models, as small and large language models with a multi-agent system approach, to be able to generate actionable recommendations from customer data. Like some examples over here, the reviews might be talking about wait, was 45 minutes, nobody told us, the app would not take my credit card, no quote was received. A legacy AI would talk about the sentiment, that's a negative sentiment. The topic is billing, the topic is communication. We had our approach targets to identify, first of all, these reviews which talk of serious issues, categorize these issues into buckets, and then give an actionable advice to the business that what they should do to fix it for future customers. Like an example in front of you right now is a real customer review, which is talking about that a customer who went to a dentist. So they had to wait for a while. They did not get the code. They were prescribed needle-based treatment, which they had panic attacks to. They did not want that. That's the review which the customer has given. So clear issues are already identified over there if we are able to extract them. But of course, manual identification is different. A generic LLM-based approach would, as you have seen in front of you, is typically going to just list out long, vague issues and long, vague recommendations. It's imperative to maintain customer satisfaction, ensure smooth operations, include more diverse treatments. It doesn't have actionable steps. That was the first thing we were trying out. A slightly fine-tuned model would be able to categorize the issues and advices for you. That what is the issue the customer is talking about, the code wasn't sent, no suitable alternatives are provided. The final review sense model, which we have right now, is able to provide highly specific and directly implementable advice for the business. If the customer is talking about these certain issues, about the correct code and needle-free treatments, and these are the advice which our review sense model gives to a business, which the business can directly implement. The business owner doesn't need to ask any further why questions. That's the beauty of it. Everything is clearly actionable. No further why or how needs to be there. That was one part of the work we are doing, where essentially it's about understanding the issues the customer is bringing in and creating recommendations out of that. Another part of it, that amongst the good things happening over there, there are many hidden gems in the customer feedback. The customer might have really enjoyed a good meal, had a good experience, still might have left out a review which is useful to you and you can improve your business. So harnessing customer genius. The customer are talking about something about your business. They are giving direct suggestions provided in the reviews, which are often overlooked. And identifying specific needs which customers are talking about in their reviews can immediately customer satisfaction and directly impact the business growth. That's this project about, that the customers are really saying maybe it's a 5-star review, great gym, nice hotel, but in that 5-star review, which a typical legacy approach might ignore, there might be certain hidden gems talking about that, hey, they are saying that although the gym is great, they would prefer a water chiller. That's a gem hidden over there. Although the hotel is nice, there's no hook for wet towels. So if you add a bathroom hook, although the food is great, the music was too loud. So here's a hidden gem over there, lower the volume at the dinner. So that's this area, that there are thousands of raw reviews which are perhaps talking about some good things also, some bad things also. Essentially, the customer is directly giving a suggestion. It's broadly a suggestion mining approach basically, but with a small language model classifier built in. So the customer is talking about certain things to you as a business, but it's like hidden on the deluge. Like some examples in front of you, amongst this long story, a customer is talking about that the migraine inducing lights were there, I had a strong headache, I could not enjoy the dinner, or the service was slow, server needs training. We extract the actionable suggestions which a customer is talking about and put them in front of the business. For example, the first one is talking about the ambience as an area, replace the lighting. The second one is talking about staff training that customer service should be provided. The third is talking about assign a kitchen manager. So of course, if you do go one review to one suggestion mapping, it will be like a huge array of suggestions itself. That would never be a good idea. So from hundreds of suggestions, we move to executive insights, basically. So as an executive summary at the CEO level, you go from thousands of reviews clustered down to certain categories of topics which your customers are talking about. And amongst those categories, we highlight the suggestions or the direct actions for a business. For example, we highlight that a number of users are talking about add more vegetarian options for lunch and dinner. A number of users are talking about wear gloves when handling food. Whichever topic there are most users talking about it, those rise to the top. Wherever lesser users are talking about it, they are a little down the dashboard ladder. So that's the broad approach of giving a final executive summary to the end user, where the business can directly understand what is the area where majority of my customers are talking about something and how to quickly put into action, like the reviews in front of you right now. So they're talking about a number of topics. Label 1 and 0 is essentially about a label 0 is that there is no actionable thing to be done. The review gets discarded. Label 1s are all useful reviews where certain suggestion is directly given by the user. So we take an input review, we discard the reviews with the label 0, we extract useful suggestions from them. The suggestions are paraphrased, however, preserving the intent. The intent is not being changed. So the suggestions are clear that your customers are talking about vegetarian options, customers talking about potential wait times, add pictures to menu. Using these suggestions, and we assign them to the right category, the category menu, wait time, etc. And we derive the summarized action item for the end business, that what your customers are saying. So this kind of an approach immediately brings a number of strategic benefits and a high end user impact for the business. It brings in high operational efficiency because there's automated identification of recommendations. There's no manual labor. It streamlines the entire feedback to action pipeline. The approach is quite optimized for CPU usage. There's minimal high-end compute requirement. All of them are optimized to work less than 10 seconds on a standard commodity hardware, which is like great for long running. And basically by transforming your raw reviews into actionable insights, this approach is driving customer loyalty and operational improvements, which will directly impact the bottom line. The approach is also quite scalable. It's built to handle a colossal scale of data. The work done was in collaboration with the company, which handles thousands of customer reviews at a weekly basis. So essentially, a lot of user data is handled on a scalable basis, providing actionable advice to the user, providing a competitive edge to a client in the busy market. All right, that's all from my side. Over to you, Srinivas. If there are any questions, I'm happy to answer.
Thank you, Professor Pratik. Is there any questions? No. Thank you, Pratik, sir. So the next talk will be by Dr. Yaman Kumar. So this is industry talk from Adobe Research.
Hello, thank you, Srinivas. I hope you're able to hear me.
Yes, sir.
Okay. Yeah. So the title of my talk is Marketing and Sales in the Era of AI Agents. I'm Yaman. I am a lead researcher in the Adobe Media Data Science Research Lab. So I lead the research division, research team in Digital Experience Business Unit. I'll go into it a little bit. What do we do? But like for Adobe, our mission agenda is empowering everyone to create, and that's like a very high goal to achieve. There are like two broad business divisions in the company: Creative Cloud and Business Cloud. So in Creative Cloud, this essentially means make your images pop with Photoshop, create like something with Adobe Express, handle documents with Adobe Acrobat. So we have AI agents which enable these kind of workflows for creatives, right? But I am in this second business division, so I'll tell you more about that part, because that's the part where we're trying to enable something along with many researchers around the world, including obviously with Pilani and Goa as well. Okay, so what does this mean for marketers? So this is the broad problem statement for the digital experience business unit, where we really want to enable personalization at scale. See, what has changed from pre-Gen AI era to Gen AI era is that content creation now can be created at scale. Earlier, marketers were limited by the number of ads that they could create for their customers. Now they can do it at scale, and that is the thing that has changed. But there are few more things which actually change along with that, right? So personalization at scale essentially means that I can create one content variant for one person, right? So earlier what used to happen was I created one ad which used to serve probably tens of thousands or maybe millions of people, right? Now can I have a message which is just personalized for that person, right? And this is a general um, um, process of how communication flows from marketer to their consumer and back. So a marketer sends out emails, WhatsApp messages, text SMSs, phone calls, Facebook ads, so on and so forth, to many different segments. These segments can be a grad student, females of different kinds, and so on and so forth. People click on it, they ignore it, they buy stuff, all those things happen, right? um, Now there are very interesting and niche problems which come up when we in this GenAI era, which can be solved thanks to the scalability and the intelligence aspects of LLMs. So first, for example, source optimization. Who should send out this email or this campaign? Should it be like the marketer herself, or an Instagram influencer, or someone else? Then how do I optimize my channels? Should a phone call be a better medium to communicate to my customer, or an SMS? What should be the auction design, for example, if I'm bidding on Google Ads? Then send time optimization. What should be the most appropriate time to send to that customer, right? uh, I talked about personalization. How should you construct that message such that it has maximum impact? How do you segment your users better? Can you do some kind of analysis on social networks? Can you make a look-alike modeling of your users, where they can behave as users? So persona uh, prompting and persona simulation. And there are like many allied problems like recommender systems, A/B testing, targeting, argument mining, persuasion strategies, which come along this entire portfolio of problems. So in NBSR Lab, we try to solve these kind of problem statements for the marketers so as to enable personalization at scale, in yeah, for them. So this allows us to answer questions such as this. For example, if I talk about audience selection, which age group will the following content most appeal most to? Then this is the campaign. The agentic marketing stack says something like age 25 to 34. Then change the following content created for USA to make it higher performing for India. Game day deserves great wings. Match night deserves great biryani. Right? Behavior simulation. I have two ad variants, A and B. Which one will the user like? Variant A. So these are the kind of questions that we try to answer, in agentic era. Then another thing is, we can try to simulate content. That if my target segment is new parents, how can I modify my message such that I get click-through rate of 2.5%, right? Make the baby face the camera rather than her mother, and that way you'll get able to get like higher CTR, click-through rate, for the new parents segment. So this enables us to empower everyone to create and go from manual execution to agent-driven intelligence. So how does this look like in in actuality? So a marketer essentially cares about like how will their consumers behave upon seeing the ad, and how can they optimize that message so as to get their desired impact. At the end of the day, they have to say that this campaign which I spent this much dollars on resulted in this much revenue for my company, right? So we're designing something called social agents, where uh, we can simulate some kind of audiences for these marketers. So given this ad, the marketer can and ask a college student interested in tech, hey, how would this look like? And the college student can say that the email is looking visually striking and creative. It uses bold imagery and vibrant design to show AI's creative potential. Like, I'll give it a potential score of 75 on 100, right? That means like I'll probably click on it. Another person might say that, I am more interested in it. As a young digital artist, this email is exciting due to its creative focus, vibrant visuals, and intuitive interface. It captures attention and sparks curiosity. The good thing is that we can now scale this across many, many users. What was not possible before, now we can actually do it. Like we can do it across millions of users. So we can have something like an agent factory where they, collaborate amongst themselves. They exchange their thoughts, and finally they come to a conclusion that this is what it looks like, and this is how you can improve it. Now, whether or not this works is another question, which we're trying to analyze and how to make it better. So yeah, so as to enable, like, again, personalization at scale for all the marketers out there. And we have had success with both many academic collaborations, and I've highlighted like a few bits collaboration we have had with several of our academic partners, to enable digital marketing in the era of LLMs. So I'll keep it short. Any questions, anyone?
Yeah, any questions? Yeah. Thank you, Yaman. It was wonderful talk, and I'm also interested with the marketing kind of thing where I work like, personally on with a LLM model. So, like, how do you work with, for example, a customer is there where you are showing the ads. So, like, for example, the 28 to 35 is the age category where the LLM model has defined. But there will be certain people who has a kind of a below, kind of income level. So, who are not potentially your customer. So, does your LLM model detects that also based on the income source level or something like that?
Yeah, so there are two problems here. One is the sourcing aspect, that who are the people out there who can buy my product, and second, once you have your ideal customer profile identified, how do you target that customer, right? So once a marketer makes this kind of decision that, hey, this is the income group which I am targeting, uh, or that these are the different, for example, like let's take maybe cred targets that 1% crowd, right? So
Right.
essentially that means they're going to target those kind of people and ignore other people. So one question is like, how can you identify amongst the millions of people out there which are those people? How would you identify them? Like no one would say that I'm 1%, right? They would identify with certain different characteristics. uh, for example, like I'm educated, like I subscribe to X and Y and Z. From those attributes, can you identify that if I belong to 1% or not, right? So that's one kind of question. And again, that is possible, much more possible now than before, just because LLMs, thanks to their world knowledge, they are able to relate that if I subscribe to X, then I must belong to the 1% crowd, right? So that's like
Got
one
it.
kind of problem which gets solved. And second, once I've identified the target customer, how do I enable like creative personalization? So what that means is, can I choose appropriate colors, titles, the message? Should the message highlight subscribe to X, or should they highlight that your family will benefit by Y if you do this, right? So different kind of strategies which will work. So those are the different things which get enabled. Yes.
Any other questions? Yeah, thank you, Aman. So
Thank
the
you.
next talk will be by Professor Pradnya from BITS Hyderabad campus.
Hi. Hello, everyone. I'll just quickly share my screen. Can you see my screen?
Yes, ma'am.
Yeah. Okay. All right. So, good morning, everyone. I'm Pragya Upadhyaya. I'm an assistant professor at BITS Pilani, Hyderabad, and I'll be talking about some work that we've been doing here over the last 1 year on making large language models inclusive, specifically for low text literate users. So I'd like to start by asking this question, that are LLM backed information systems inclusive for all? Okay, all when I say all, it means I have the spectrum of category of users who can use LLM-backed information systems, but we can categorize them into advanced users who are highly proficient in both literacy and digital skills, can build different functionalities, can navigate complex applications, etc., etc. So example would be people like us who interact with such systems on a daily basis and are also involved in developing such applications. Next, we have digitally literate users who are also quite literate and quite comfortable with these systems. And they use it on a day-to-day basis. Not as much as advanced users who can make up different functionalities, who can build different functionalities, but they are also quite adequate in handling such systems. Then we have the functionally literate users. Examples would be the cashier at a grocery store or any other retail store who can actually use these systems. They can read and navigate complex interfaces. Then we have two categories of users, semi-literate and illiterate users, who have basic reading and writing abilities, but limited proficiency. They can comprehend simple text, but they struggle with complex instructions or dense information. Okay, and more than that, we have the illiterate users who do not have this ability at all. So the thing is, the last two categories, they form the next billion users. So the first billion users are us, people like us who are comfortable with such systems. And of course, all of these systems are getting LLM backed. But these are the category of users that we are interested to know how they interact with an information system which are LLM backed, or any information system provided. So let us have this example of a person wanting to know the benefits of Jan Dhan Yojana. So it is a scheme provided by the government of India for underprivileged users, and they would like to know how to apply for the scheme, what they are entitled to, know their rights, etc., etc. So if such a question is asked to a system, LLM-backed information system like ChatGPT, it will give us a text-heavy response. For instance, so this is the output from last year. Of course, there's a lot of changes right now, so I'm not going into the exact way ChatGPT responds to, but this was what we got from using ChatGPT 4.0 from last year. And you see it gives the output in a very text-heavy format. It will give you a sequence of steps and so on and so forth. Now, the thing is, people who are the next billion users, they are unable to comprehend this dense information and convert that into actionable steps. So what would be beneficial is if we had a system that can convert, that can give the answer to a query in the series of actionable steps to be done for such low text literate users. So keeping that in mind, we built this system. We built this application called Prabodhini, which gives answers to complex queries and information in the form of actionable steps. And the way it does it, we define a different information retrieval task, which is called actionable information retrieval, where we ask questions one after the other. We prompt the user, and the interaction based on the output of the user, the next question is asked, the series of follow-up questions are asked. So this makes even low text literate users who are not equipped with navigating complex interfaces comfortable in handling, in availing useful information. So in this case, we worked with the data from my scheme, which has different schemes listed for different users from different regions of India. And we have built this application, which is also available in three regional languages, Hindi, Telugu, and Tamil, apart from English. So the way this system works is it takes the query and it categorizes it into three types, into informative, procedure, or yes or no. And based on that, uh, it chooses the best question to ask to the user in the next step. And based on the response, it generates the next question until the user is satisfied. I'll show a demonstration of the system in the in my presentation. But the thing is, this application has been actually we did a pilot study here at BITS Pilani campus among users comprising housekeeping, gardening, and household security staff here. And they reported a high level of user satisfaction with positive feedback across all participants over usability, design, and functionality of the application. So we also did another evaluation of this application with the MyScheme government website, or the MyScheme app, which also allows users to ask questions about these schemes and on procedures to apply for these schemes. And what we observed was the complex form-based interface of MyScheme offers problems of gulf of execution gulf of execution. That means a user has to translate their needs in the format of the conversational interface they are using, instead of the most natural way of conveying the information to the information system. And Zipf's law of least effort states that a user wants to spend little cognitive power to interact with the system, specifically for our user group. So based on this, we did a comparison between our developed application Prabodhini with MyScheme, and we found that users which use our application, they could complete a task at less than half time as compared to using MyScheme. So Prabodhini bridges language and trust gaps with familiar voice interaction, unlike MyScheme's rigid text-heavy design. So the key feature of Prabodhini is voice-based interaction, which I'm going to show through this demonstration. So I'll just play this demonstration video, which is hardly 5 minutes. So I hope you'll be able to hear the video play.
Our application aims to bridge the gap between people in need.
Can you hear the video?
Yes, ma'am.
Okay.
Need and accessible welfare schemes. Users can ask questions about unique situations like seeking shelter, financial assistance, or educational support for quick and relevant guidance. This makes it easy for users to access and understand support available to them.
लाली बाई योजना को कैसे अप्लाई
The system categorizes each query into yes or no, procedure, or informative type questions, defaulting to informative type. It matches the appropriate schemes to give clear step-by-step instructions, eligibility details, or direct answers. Here in our application, we're able to choose our input language, set here as English, and our input state, which is additional information that is passed on to the query, and also input our query. This is processed as a yes or no type question based on the query that we've entered, and it provides a direct response. The voice input feature in our application makes it even more accessible and user-friendly, especially for users that may have limited literacy.
How can I change my address in the Aadhaar card?
Here, as you can see, we have inputted the query via voice input. Based on the query, it is categorized into a procedure-based question, and we receive step-by-step instructions for our query on how to change our address in the Aadhaar card. Our application allows for input in the following regional languages: Telugu, Hindi, and Tamil.
కంటి వెలుగు ఎలా అప్లై చేయాలండి?
This translates to how to apply to Kanti Velugu scheme.
So, in brief, first it asks if we are from Andhra Pradesh, and it explicitly mentions that the scheme is only available in Andhra Pradesh. It then proceeds with further step-by-step instructions such as, do you have an Aadhaar card or identity documents? Or in your village, can you go to the nearest healthcare facilities? Once I click on yes, it says, can you get the application from there? It lists the documents required and asks if you can submit them, and asks if you want to know about your application status. Then either ask officials or check the official website. This particular query type produces an informative type answer. Here, our application is listing the schemes that are available for disabled people.
अगर मेरे साथ कोई दुर्घटना हो जाए तो मुझे क्या मदद मिल सकती है?
This translates to, if I were to get into an accident, what help could I get? This produces an informative type answer based on question category. You can get help in the following ways. For example, if you're a construction worker in Rajasthan, there's a scheme providing medical and financial assistance for injuries sustained on job. Then in Maharashtra, there's a program that offers financial support to farmers who became disabled due to an accident.
This application continues by listing more programs such as these.
ఈ యాప్లో ఏం నచ్చింది మీకు?
తొందరగా ఇన్ఫర్మేషన్ దొరుకుతుంది.
आपको जो कुछ भी आप सर्च कर रहे थे, आपका इन्फॉर्मेशन मिला?
हाँ,
करेक्ट था? तो कितना मार्क्स देंगे?
5/5.
ఒక్క 100%
దొరికిందా? तो మీకు మున్సిపల్ ఆఫీస్ బెటర్ అనిపించిందా ఈ యాప్?
యాపే బాగుంది. ఇప్పుడు ఆఫీస్కి తిరగాలంటే ఇప్పుడు పని కూడా కొట్టుకొని దినం మొత్తం తిరగాలి. వీడియో కూర్చొని చేసుకోవచ్చు మనం అట్లా.
Yeah, so that was a demonstration video of the application and the work on LLM-backed conversational interfaces that we've done so far. So that is all from my side. I'll be happy to answer any questions. Thank you.
Thank you, ma'am. Any questions? Yeah, thank you, ma'am. Now next.
Thank you.
Next talk will be from Crest Proloy.
Good morning, everyone. I hope you can see the screen.
Yes, brother. We can see.
So thank you, Srinivas, for inviting Crest for this opportunity, and we are really happy to give this. So we'll basically give a informative presentations, not too much technical point from our side. Crest is a center of excellence for the research in semiconductor technology. So we will briefly discuss about the contribution, impact, and roadmap in entering the global semiconductor roadmap. So basically, the context of this show is that we have a mission that is to make public and private investments and keeping in mind that the semiconductor missions, quantum technology missions. And the focal shift is the semiconductor manufacturing to India, and obviously the need in the academia, industry, and government linkages, build research and innovation capabilities, and also the capacities. And we do a lot of skill manpower development program. As the government of India, as well as several companies are investing a lot of money, so I'm expecting that there will be high jobs in this area in coming 5 to 7 years. So if we talk about the phase journey, so it is our Central Radical Lab launched in 2015. So we have a clean room. We have different labs for the microelectronics, for the 2D materials, for the analytical device lab. So we launched from case level projects, and also recently launched the top tape out projects. So it will be from the design to the final product, and we are state for the augmentations and intense outreach in the coming years also doing this thing. So we have a clean room, as mentioned, in the Hyderabad as well as all the other Pilani and Goa campuses for the class 100, 1000 and 10,000. So our study enables are in the nanofab characterizations and HPC validations. It's gone to the materials, devices, applications. So it will start from the 2D materials, catalytic materials, to piezoelectric, composite, heterojunction, optical and photonic materials, for to name a few. The devices work to the FTT, MEMS, microfluidic, memory stud, and so on. And the applications range from the sensors to coatings to the energy harvesting as well as in the environmental area. So if we particularly talk about the AI things, so AI-enabled EDO tools, modeling and simulations with projected research is going on. AI, ML, DL, augmented sensors and IoT systems people are doing all. And the hyperspectral camera for smart sensors and energy harvesters. And we have in the base system has a unique program. Hello? Srinivas, I am audible?
Yes, you are audible.
So we have a unique program for the PhD driven, and that is take that at the end of the PhD, that students or the research scholars will be with a final product ready in this or start making a startup. So BITS has launched and case is supporting more than 7 PhD scholars in that range. And recently launched some paper projects with all the BITS faculty across all the campuses that they are doing from the design to the fab. So one of the example we are giving, like the Smart Hill, which is from Pilani campus, that AI-enabled wearable devices using e-textiles for recovery and pain management. So we are also involved in this AI area. So ICRES is also involved in the Indian semiconductor mission. That is recently the launch there are 12 technologies. So our Professor Venkatesh Rao from the Pilani campus is involved in the mechanical sensors. And we have a good relations with IESA and another ISM and other things, and the other agency called IDSPS. So in terms of skill manpower development, we lot of do in the hands-on fabrication in the semicon area, and also the modeling, theory, simulations, experimental, all the area in the winter school, in the summer school, and also launch the class 11 students from the India Ganna Vidyalaya. We do a lot of IIT enables cyber-physical systems, so local by colleges, and we do multi-collegium. That's, for example, next collegium 20 phase, that is on deep learning from the professor from MIT, Professor Yasas. So he'll give presentation. So we have a lot of industry partnership and entrepreneurship. As for example, Micron and Tech Mahindra, AMD, UST, Resolve, and all, to name a few. So we have also got some industry-oriented projects. That is, for example, we got from the ASM HHB, that is the development of the laser-assisted CVD systems, and most probably that will be installed in the Goa campus. And also we got a project on from Ministry of Electronics and Information Technology on the dosimeter. And we launched different courses. Just for example, we have minor program in semicon and have the MSc in semicon and nanoscience. And we'll do the professional development course and packaging. So recently the fourth PDC is also going on the weekend evening. There are a lot of industry, a lot of faculty, a lot of students are involved, and that is basically the weekend evening. So recently in the BDC course, we have educated more than 600 people, and there are a lot of, very, very expert speakers are coming across the globe. And this time we are launching it we have done it from the IMAPS, BITS Pilani, and also the IDSPS with the Professor Tumala Rao from Georgia Tech. For example, for more industry, we do the Lam Research Semiverse program. So they have given us some license software for the device fabrications, so that remotely we can control the instruments. As I said earlier, we have launched the tapered projects, and we are trying to do that from the final product thing. And we are recently with the IIT Hyderabad, BITS Hyderabad, Central University of Hyderabad, and CMAT together launched a program called Anunath. That is together they will form a clean room that, and that's coming under the ANRF and Ministry of Science and Technology. So I will not tell more further. So thank you for calling, and thank you all our head and our associate heads and all the things. Thank you so much. If you have any questions, please.
Thanks, Pranay. Any questions for Pranay? So we'll go with the next talk. So the next talk will be given by Professor Aditya Chella. He's a professor in BITS Pilani Goa campus. Over to you, sir.
Yes. Sorry, just a second. I think I have to give the access to the screen.
Hello, Srinivas.
Yes, sir.
Yeah, I
Yeah,
think you can have the
sir
next talk, right?
Yeah. So we'll have next talk by Dr. M. Rama Manor Babu from CRILS.
Sorry, I missed. Should I continue?
Babu, sir?
No, I think let's follow the slot, Srinivas. I
Yes,
think
sir.
Professor Aditya is here now.
Yes, sir. Aditya, sir, you can continue, sir.
Oh, yeah, sorry. There was some preferences issue and I had the webinar quit. Let me know when you can see my slides.
Yes, sir.
Yes. Hi, sorry for the inconvenience. So my name is Aditya. So I'm a part of a group which works on distribution and robust intelligence. And we usually focus on the foundations and of machine learning. So, so these are our collaborators. So, and the aim of our lab is to work on robustness, basically using quantiles and try to solve calibration problems and anomaly detection. More into that later. So let's start with how AI systems are built today. So everyone follows the same cycle. So you start with some data. You start with building a model, you evaluate, and you keep on retraining, and you keep on iterating it. And for a large extent, this has been a very successful way to build these systems, fundamentally because of two underlying theoretical results, which is only recently well understood. First, neural networks, especially the deep neural networks, they predictably extrapolate as linear models, which means we know sort of how to control these systems, at least in the nearby space. The other key result which we know is that they can actually learn the underlying skills when you give them different combinations of data sets. So for instance, if LLM can learn sorting in Python and searching in C, it somehow is able to sort it in C, although we didn't give that explicitly. So these are the two main things which worked quite well. However, if you look at it closely, the key thing which people sort of exploit everywhere is the data set. And Our argument is that this is these small wins are a Pyrrhic victory, because although we can use data sets to beat pretty much any benchmark we can think of, all we need to do is come up with novel ways to add new data sets or synthetic data set, or maybe some small modifications. But relying too much on data set gives a lot of different problems. First, there are privacy issues, copyright issues, biasness issues, and unfortunately it doesn't really solve the core problem which has been existing even before the deep learning era. So what is that problem? So one of the biggest problems, even before deep learning and any of them took off, is something which we call distribution shift. So this is a very fundamental ML problem. So to explain it briefly, basically say you have an image on which you trained your model and you use some sort of particular sort of noise, then your model doesn't work well. But of course, I can sort of hear you thinking that, okay, if that is the case, then how come all these LLMs, especially, the recent Claude Codes and Go-Works and all, are working so well? The answer to that is the current approach. Basically, whenever people think of a different distribution shift, they just include it in the dataset. And while that does give good benchmark results, the issue is it's not elegant, it's quite inefficient, and also quite costly. And more importantly, yes, today's shift we can consider, but what if something else changes? So our aim is to provide a principled solution. So I'll talk about 4 different ways which we use to solve this issue. So there is a very famous, very old equation which is widely used, which is that if x is any random variable, then if you take fx is this cumulative distribution of the random variable, then fx of x is always uniform. This sort of motivated us to consider, now this can actually sort of make all distributions map to uniform pretty straightforward, right? So this is why we introduced something called quantile activation. So the idea is basically simple. So assume that you are getting some particular set of input. You look at its own distribution. This can be a particular neuron or even inputs or outputs. You look at its particular distribution, but instead of directly taking the raw activation, you only take the quantile of that with respect to the distribution. This way, even if the input changes the distribution, even if if the distribution is different, the fundamental edge weights and all can actually maintain the same. Of course, there is one issue here, which is that the indicator function is not necessarily differentiable, and the way we sort of overcome it is using the kernel density estimates. So these are some initial results which we get. If you look at the figure on the left, you can actually see that the drop in the accuracy is quite less compared to even the state-of-the-art models like DinoV2. And these are like very basic results where we don't use heavy data augmentation and we rely on very simple techniques instead of the recent data, because the whole purpose was reduce the importance of data. The other advantage of these quantile methods is you get a very nice property for free, which is called calibration. So what is calibration? So when we say something is a probability of 0.8, implicitly we all understand that it means that, if 100 people claim they are 0.8 confident, then 80% of them are right. So that is a fundamental fundamental property of the probability which our outputs of ML outputs should hold. Unfortunately, neural networks don't hold this. So thanks to quantiles and especially a nice property called duality of the loss function for quantiles, where we get that calibration is completely obvious. So if you look at the results, you can see on the right hand side figure that even if there is a very big distribution shifts, our calibration results are more or less constant. Like we don't change the calibration error at all. Unfortunately, the other methods actually increase the calibration error, which means that even if the output might be right, it's just that you just don't know how confident you can be about it. However, so we fundamentally used one-dimensional quantiles till now, but there are actually a high-dimensional variants to it. So to skip a lot of math, the high-dimensional, so you can think of quantile as identifying the position of your point in the distribution, right? So similarly, you can think of a high-dimensional quantile as the position of position of the point in the high-dimensional distribution. So the best analogy I can think of is if you look at a map, the latitude and longitude, the two latitude comma longitude will identify a specific position of the map. And if you have to combine two different maps, the way two different maps can be matched is by using latitude and longitude. And it turns out that using this simple result, we actually get quite a good results, which is sometimes better than state of the art in several models. The last trick which we use is again a very old tool called Radon-Nikodym theorem. This also allows mapping one distribution to the other. The theorem basically says that if you have two different distributions, you can find a function which maps one from the other, which is very simple. And we have actually used it for anomaly detection, because we can actually think of anomaly detection as a distribution shift. And it turns out that across wide variety of data sets, we actually have beat most of the state of the art methods, even transformers and everything, with this simple mathematical change. So all in all, the few things which I wanted to highlight here: first, distribution shift is still a fundamental problem and it's unsolved. While the current approach of handling distribution shifts is just take all possible distribution shifts and train on them, that's not really the most elegant approach. And we need some more principled mathematical approaches can actually go quite far. And finally, I would want to highlight the fact that just because we have high accuracies doesn't really say about the complexity or the computational cost of the underlying method. Thank you. Any questions?
Thank you, Professor Aditya. Any questions? We'll go to the next talk by presentation by CRENS team. So Dr. M. Rama Manohar Babu will present from CRENS. So he's head of CRENS.
Yeah, I'll share it.
Yes, sir.
Entire screen. Open the presentation and actually share the entire screen. Is it visible? Is it visible?
Yes, sir.
Yeah, I am presenting on Center for Research Excellence in National Security, the CRENS. It is a Center of Excellence started last year. And along with me, Professor Rahman Saab is there, is the advisor to the CRENS. And in fact, this particular center was inaugurated in August 2024. And it was a strategic and a unique initiative by BITS Pilani. And the major goal of CRENS was to play a pivotal role to develop homegrown cutting-edge technologies as well as high-skilled set of human resources in all the spheres of national security domains by collaborating with various national security stakeholders in an integrated manner. And we defined our vision to emerge as the national leader in advancing state-of-the-art research, fostering innovation, skill development, and building a resilient ecosystem for addressing complex challenges in national security. And in fact, now we have the mission to collaborate with all academia, government, industries, and startups to address critical challenges in national security domain, and also to enhance the capabilities to empower professionals and stakeholders with advanced skill sets in various emerging technologies, and driving strategic research in key emerging technologies, promote self-reliance in national security domain, and also to expand global outreach to address national security challenges. And this particular center operates across all the campuses, integrating the strength of faculty and research scholars and all the research infrastructure on one hand. And we wanted to collaborate with all the stakeholders in the national security domain, right from MOD, MHA, and research labs like DRDO, ISRO, DAE, and industries, which includes all the public sectors and as well as private industries and academia and also startups. And we have three verticals under this. One is research in cutting edge technologies, and second is mentoring young innovative entrepreneurs to incubate startups. And the third vertical is skill development for the working professionals in the cutting edge technologies. And all the verticals together, the objective is strategic to enhance the national security capabilities and make the country self-reliant in the national security domain. And we have constituted an advisory board with high-profile people. Dr. Satish Reddy is the chairman for this advisory board. And we have members from various national security domains. In former naval chief is there, and former atomic energy chief is there, and we have taken from police department and industry and as well as academia. And for the day-to-day guiding for the scrums, we have also formed a steering committee. And as far as the initiatives what we have taken in the last 1.5 years, and also before starting the scrums, we have scanned through all the projects being handled by BITS Pilani of all the campuses. And we shortlisted the projects which are in the domain of national security domain and integrated them to CRENS. And as of now, we are handling about 70 plus research projects and in the areas of the national security domain funded by various national security related agencies. And some of them, they are also actually with the subject AML, because this particular summit, we are interested in the AML, and I'll show you in the next slide. And as far as the second vertical is concerned, the skill development vertical, and we have started recently one professional development course in cybersecurity for all the working professionals in various national security domain to enhance their skill set in the cybersecurity, which is a challenging and upcoming area. And we have completed the first batch, and participants were about 90 from all the domains, right from armed forces, DRDO, ISRO, and industries, etc. And as far as the third domain is concerned, third vertical, for mentoring the innovative entrepreneurs, we wanted to focus on even the young entrepreneurs, even outside the Pilani campus. And if they come forward to make a startup in the any field of national security domain, we wanted to help them and mentor them. And for this, we wanted to start a separate incubation center, which we wanted to focus totally on national security domain. We'll come out with a plan very shortly in this particular activity. And as I said, we are handling about 71 plus projects. And out of this, The AML related projects, I just made a list. The number one is smart crop planning. That is AI, artificial intelligence based decision support system for crop diversification. This was funded by ISRO. And machine vision based adaptive quality assurance system for aerospace vehicle assembly unit. This was funded by DRDO. And development of deep learning framework for auto quality certification of all IRS optical satellite images. This was also funded by ISRO. Defend IoT based cyber espionage with analysis of encrypted and unencrypted network traffic with the machine learning algorithm. This was funded by DST. Computer vision based search and surveillance system for detecting human activity. This was funded by DRDO. Artificial intelligence based technique for predictive atmosphere visibility. This was funded by DRDO. AI enabled security provision and vehicular vision innovation for autonomous vehicles. This was funded by SICA. And AI and blockchain enabled security for the healthcare applications. This was funded by DST. So all these projects were related to AML technologies. And in fact, the grants, we wanted to concentrate on all the emerging technologies which are very important for the national security domain. And the country has to become self-sufficient in all these emerging technologies. I don't read all of them, and few of them like hypersonic technologies and advanced manufacturing and high altitude technologies, optics and photonics technologies, robotics and automation, and unmanned vehicles, electronics warfare, and MEMS and NEMS, CBR and technologies, quantum technologies, stealth technologies, terahertz technologies, and also AML deep learning technologies, advanced food technologies, and advanced small arms technologies, high power systems. All these areas we wanted to work, and we want to actually map the capability of the faculty and the research scholars of all the campuses, and then whichever is the national security stakeholder interested in this particular areas, we wanted to collaborate with them and enhance their capability by developing the technologies in this, and as well as we wanted to develop capsuled courses in these areas so that whoever is interested, especially the working professionals, we can give them certification courses. And under each of them, the various, under each of the head, the detailed technological areas also, I am preparing one document, a vision document, and this will become the basis for both innovative research and as well as skill development courses, and also will support the startups by the young entrepreneurs in any of these areas. And of course, as I said, I am heading this class, and Professor Rahman Saab is the advisor. He recently joined, and associate head from all the 4 campuses, Professor Amrita from Hyderabad campus, Professor Radharaman Mishra from Pilani campus, Professor Vaibhav Joshi from Goa campus, Professor Harpreet Singh from Dubai campus. Okay, we are about 1.5 years old, so we are going forward. Any suggestions from anybody, I welcome it. Thank you.
Thank you, sir. Any questions or any suggestions from the team? Yes, sir. Thank you, sir. So the next talk will be by Professor Navneet Goyal, Professor at BITS Pilani campus.
Hello. Very good afternoon to all of you, and thank you for this opportunity. Let me share my screen. Yes, can you see my screen?
Yes, sir. Blank screen has come. The slides are not visible.
No?
No, sir. I can see a background. But
Sorry?
no slides. I can see the background, but no slides.
But here I'm seeing it is showing. Let me try one more time. Let me try one more time, otherwise I'll forward the screen. Is it visible now?
No, sir.
No. Oh,
Yeah, something has come up.
can you just check quickly?
It's black screen, sir.
No text?
No, sir.
Okay, so shall I send my presentation? I think there's some problem here.
Okay, sir.
I'll just quickly send it to you. Shall I send it to Srinivas, right? Yeah.
Yes, sir.
Just in a bit, I'm sending. Okay, I'll send it to you, Srinivas. Can you just check it?
Yes, sir.
Yeah. Thank you, Srinivas. Yeah, I hope everybody can see my presentation.
Yes, sir.
Yeah. Can you see? All of you can see? Yeah. Thank you. So I'm going to talk about the work that we have been doing for the last 4 or 5 years. And we have seen there are a lot of opportunities in this area and also a lot of challenges that we need to overcome in order to have something impactful. So mainly we are talking about AI for satellite data and the challenges and opportunities that are there. So it is basically our work is focused on synergizing two disruptive technologies for impact. And next slide, please. Yeah. So the preamble is that there have been rapid and exciting developments in both satellite and AI technologies. And both technologies have disruptive potential of their own, and there's a natural synergy between them. And as we move forward in time, more and more complex data and complex and efficient AI models needed for more detailed images. So we are now in a position to capture different modalities of hyperspectral data using advanced technologies like SAR. SAR is not new, synthetic aperture radar, multispectral and hyperspectral. Hyperspectral is something new in terms of satellite data. So we are able to capture more and more details. So in order to kind of find patterns in such images, we need more complex and efficient AI models. So that has been the focus. And satellite technology provides the advantage of scale, which we need to, which we can leverage. So that is the opportunity for us. And there's an ever expanding spectrum of application domains like agriculture, forestry, rural urban planning and infrastructure, oceanography, environment, climate change, disaster management, defense and security, and of course earth sciences. Like there has been some recent focus on rare earth materials, so this is where can come. And some of the recent developments in both these technologies. So as I said, there are a lot of new modalities that are coming, and the data is being made available to researchers all over the world. And there is a new satellite that has been launched between in collaboration with India and US, NISAR, and it was launched in July 25. And now the data is being made available in India by ISRO. And there is this hyperspectral data, which is being captured by one of our own startups, Pixel. And there's an IIT Madras startup, which is now capturing data from SAR and multispectral modalities. So these things open up a lot of opportunities for us to leverage this data and work on some very important use cases spanning multiple application domains. And then recently, I mean, just a couple of days, 3-4 days back, we heard that there is like Elon Musk announced the merger of XAI and SpaceX. So this tells us that there's a lot of synergy between these two, although their aim is to primarily take the computing to the space, and they have plans to establish data centers, AI data centers in space. So although we are not going there on that side, but we are mainly focused on the application side and developing efficient AI models for analyzing satellite data. On the AI side, computer vision models for satellite image and satellite image time series. So these are very, very important. So we need to develop efficient pipelines for these. And of course, we can also use vision language models and domain-specific LMMs. So we are mainly focusing on large multimodal models. And our work has mainly focused around agriculture in the last 3-4 years. So next slide. Yeah. So the challenges are in terms of the heterogeneity in resolution. So if you look at the different satellites, they offer different spatial, temporal, and spectral resolutions. And so fusing them into a coherent data set is a big challenge. And that is where we are working on. And then there are different technologies like active and passive sensing technologies. Passive sensing has some limitations in terms of weather conditions and day and night conditions, whereas active sensing overcomes all these limitations. So specifically the SAR technology. And again, how do we combine active and passive sensing data for different applications? So that is again a big challenge as well as an opportunity. And data volume, so as per the latest data, there are around 1,000 plus Earth observation satellites in orbit. So the data volume is expanding, and we need the good compression techniques for this data. And another challenge with satellite technology is that massive pre-processing is required. And if you're talking about active sensing, then this pre-processing step is huge. I mean, it takes a lot of time and resources. And another challenge that we have noted in terms of real-time and near real-time applications is that there is a 2-3 day or 3 to 4 days latency in making usable data available to end users. So this is what we are trying to optimize or reduce. And then in terms of artificial intelligence and inefficient pipelines for analyzing satellite image time series, lack of generalized fusion models, lack of multimodal models, and of course there is this power guzzling AI data centers which are creating problems for us. So next, please. Yeah. So the opportunities are like how can we extend the algorithms to tackle near real-time and real-time applications, especially in terms of say defense. There are a lot of applications around this. And how do we leverage the advantage of scale to develop globally generalizable solutions. So this is another challenge as well as an opportunity that your model should be globally generalizable. You don't need to develop models for every region. So that is another important thing. And the next thing is technology abstraction for all stakeholders. So this is what we have been doing in terms of agriculture. So we are saying that we abstract everything for the farmers and other stakeholders in the form of a LMM, right? So which we call as Krishi Samadhan. And we have introduced this concept of Agri Smart Village. Can you press the next button? Yeah. So every farm is geofenced. So what we mean by an Agri Smart Village, so every farm is geofenced and every farm is digitally literate, and they are all registered with this app that we are proposing. Yes, next. So what we are planning for the next few years is to set up a research center, which we call as XI, which will be among the first few research centers globally to aim to integrate these two technologies and establish new collaborations and strengthen existing ones, and also plans to have a startup a couple of years down the line and onboard more AI researchers from BITS Pilani and collaborating organizations. I'll give you a list of organizations with which we are already collaborating and engage more actively with domain experts. So one of the things here is that everything is becoming more and more complex. So the more details we know about the domain, the better AI models we are able to develop. And this should give you some idea about the different application domains and the kind of use cases that we are working on as part of XI. So a lot of work in environment and climate change and disaster management and rural urban planning and earth sciences. And of course, the main work has been so far on agriculture and food safety systems. So I'm not, yeah. So basically this is what we are trying to do, create an AI middleware between the space technology and application domains. So this is what we are trying to do in our lab. Yeah, next. Yeah. And this gives us sense of our collaborators. So the green ones, BITS Pilani already has MOUs, active MOUs with them. So NRSC in Hyderabad, Pixel, Bangalore, then some universities and industry, and then some agri-food companies like IFCO Kisan and Agri University and AgriSat. And we have already submitted some joint projects with IIT Delhi, University of Minnesota, and Wadia Institute of Himalayan Geology in Dehradun. And we are in talks with some other organizations related to what we are doing. And this is what we have been doing. Like some patents have come out of our work. So mainly we are focusing on developing AI pipeline, efficient AI pipelines for satellite image time series. And this patent has been published already, but we have still not been granted this. Hopefully it will come this year. And then we have also developed a foundation model by the name of Cetran, so which kind of you can use it for many different applications. This foundation model. Next, please. And these are some of the publications that have come out of our work in this domain, AI and satellite systems. So some 6 to 7 publications. And yes, next, please. And with that, I'll end. And thank you very much. And this is the core team that has been working on these problems and developing better AI algorithms for satellite data. Thank you.
Thank you, Professor Navneet. Any questions? So we'll go with the next talk by Professor Rishikesh. Hello, sir.
I'm audible, am
Yes, sir.
I? Right. So let me share my screen. I hope my screen is visible.
Yes, sir.
Yeah. So I'm Rishikesh. I'm in computer science department in Hyderabad campus. I lead a research group called Sambhashana, and we primarily work in uh, currently benchmarking and evaluation of LLMs, in particular for Indian languages. There are also linguistic aspects and knowledge graph based aspects to the work. Grounding. Overall, the work is towards developing reliable systems, explainable systems. So hallucinations are a core part of it. So today I will primarily talk about one of our recent benchmarks that we have created, which was presented in the Bhasha workshop at ASEL in December. So it will be primarily about that work and some more related work towards building reliable systems or building explainable systems. Right? So I think most of us know what hallucinations are. These are fluent and confident outputs, yet they are the wrong outputs. So we have seen several examples of it. Whenever new example is found, it takes the internet by storm, saying, "Oh, LLMs are failing at this particular example." Starting with a simple example of how many R's were there in how many R's are there in strawberry. And even if we test now, a lot of models will still answer the as as 2 hours or 3 hours. Right? So this itself is I mean, that is one type of factual hallucination. The other type of hallucination is which is more pertinent to Indian languages, which is when outputs can be in different languages. So question could be asked in an Indian language and answers is either given in a different Indian language, or it is given in English, or it is given in some code mixed form. Right? So there are two primary types that we target. And in general, it is clear why hallucinations matter. It is hallucinations are they are highly I mean undesirable in higher stake situations such as healthcare and legal services. And in general, you don't want your model to make mistakes. So in a formal sense, you say something is a hallucination when model is generating the output as y, and there is no source that can corroborate y, or that can uh, sort of justify why that k has been said, right? And the technical reasons for this are often related to the way models are trained. So training objective for a lot of models is not factual generation per se. They have uh, things like next token prediction or masked language modeling and so on. So the models are trying to learn language. So it is right there in the name that these are language models. It is actually a surprise or a case of every point of investigation why models actually perform as well as they do for factual or even reasoning tasks. So the reasons behind that, how language encodes knowledge, etc., that becomes a topic for another discussion. But these naturally, if you understand the internals of model, why they hallucinate becomes really apparent. And another sources of hallucinations are exposure bias and knowledge conflicts, different facts in training data. One document is saying X, other document is saying not X. Then definitely model tries to learn both of these partially, and it may generate so partially. The long tail distribution, where majority of your terms have low occurrences, so their representations are harder to learn. And these issues get amplified for Indian languages because already the data is sparse, the entity representation becomes weaker, our vocabulary is larger, the graphemes and morphemes are larger, so more embeddings to learn from lesser data. Therefore, hallucination rate definitely becomes higher. Now, uh, when these, so again, by hallucination, why do models hallucinate, as we have seen? Why Indian languages, or why is it of interest? One, because we are all working, or we are all Indians, and we are using multiple such languages on a daily basis. And despite linguistic diversity, despite amount of literature available, from computational point of view, digitally a lot of languages are still low resource. There is a large underrepresentation for Indian languages, and added that with the script variation, the code mixing, overall the hallucinations are more apparent, and more prevalently, or more importantly, identifying these hallucinations requires good benchmarks. Identifying what, so before you can solve a problem, you need to identify a problem, which requires benchmarks, and that itself are the benchmarks themselves are scarce for Indian languages. So we tried to address that gap by creating a benchmark for Indian languages. So we targeted 4 Indian languages along with English, and we collected data across 9 different categories, collected or generated data. And among these categories, there were, for some of the categories, there are domains also which are relevant. So for example, for factual questions, there are several domains. It could be medical domain, then legal domain, science, maths, or country specific, geography, history. A lot of such domains were considered. Overall, 36,000 plus questions were generated, accumulated, curated, and then 14 models of various varying parameter size were evaluated. 2 prompting strategies were used for each question. So native language prompt and an English prompt. So this amounted to more than 280,000 evaluations total. So that is number of questions into 14 into 2. And I'll present the results of these. So together, this we call this benchmark as BRAHM-IL, so which is benchmark for hallucination recognition and assessment in multiple Indian languages. And coincidentally, the word Brahma also corresponds to confusion or hallucination. So there are 2 types of hallucinations that are addressed. What are the one, whether the answer is correct or incorrect, and second, whether the language of the answer is correct or incorrect. The 9 task categories are shown here, which include general factual knowledge, India-specific factual knowledge, binary judgment, chronological ordering, where events from history are presented to models and their task is to order them in the correct chronological ordering. Math-related questions, reasoning-related questions with MCQ options. So a scenario is presented and possible reasonings are given, and the model has to choose from it. Semantically incorrect prompts, more about this later. This is the specific category that does not exist in literature before this. NER, which is a common category, and word ordering, or also known as sentence reordering, which is ordering words within a sentence. So we take common or normal order sentences and jumble up words, and the task of the model is to put them in correct order, and the category specific metrics for each. So overall, these categories cover factual knowledge, numerical reasoning, and linguistic abilities. The creation pipeline for everything was we choose sources based on the type of category. So in some cases, Wikipedia and Wikidata were the sources for factual knowledge. Then mathematical questions were generated directly from the formulae. For some existing data sets, multiple existing data sets were collated together. In some cases, LLM assisted rule based generation was used. In some cases, manual template based generation was used. Then the questions that were ambiguous were filtered out. Questions that were not of high quality, they were filtered out. Then a high performance model that is known to perform good translations was used to translate from English to Indian languages. And then these translations were validated using speakers who speak those languages, English and those languages. So this basically resulted in the data set that we created, and random sampling based evaluation was used to ensure the output still is sensible. And the one category that I mentioned, novel contribution, is semantically incorrect questions. So these questions themselves are asking about wrong things. For example, who is the Prime Minister of Gujarat, where states have chief ministers and not prime minister, or things like what was Mahatma Gandhi's Twitter handle, or giving a wrong fact and asking for a reason, etc. And one of the findings was that models go along with your premise, and instead of, so models in these cases were given a choice whether to mark it as invalid or to give an answer. And in most cases, models choose to answer rather than rejecting these. Now, for performing these, we evaluated 14 models. The smallest model was of 270 million parameters, so we used various variants of Gemma 3. And the largest model was GPT-OSS with 120 billion parameters. And we used primary score, which was listed earlier. So in most cases, it was exact match. In some cases, it was Kendall-Stau for ordering related questions. And then we added a step of language correction. So once the model has answered, we have first detect whether what is the output language. And if that is different from expected language, we check if it is one of the languages that we have available, one of the languages which answer is available in, and then we translate, then we use the answer from that language and evaluate it. So even if the model gave output in wrong language, we still see if it is factually correct or not. We also tested some India-specific Indic models, the Navarasa 2.0 and Krutrim. So these were the models that were consistently in top 10 in some previous benchmarks, such as Pariksha by Microsoft and some other benchmarks. And prompting strategies, as I mentioned earlier, was English and native language. Now, some results, primarily these are numbers. The highlight of this should be that most of the scores are relatively low. Even the 120 billion parameter does not cross 0.44 on primary score and 0.61 on language corrected score. So this gives us two primary takeaways. One, this benchmark serves well as a, so this is a hard benchmark. So if it serves as a good benchmark to test your model on, so that you can ensure if you are able to beat these baselines, then your model you can claim to be better. Second is there is still a gap between primary score and language corrected score. So in this 0.15, roughly 0.15 gap, that is to say that language hallucinations are prevalent even in large models of parameters up to 120 billion. So definitely the larger models are still not as good at for Indian languages. Again, more comparisons, we'll see in most cases after language correction, the score is increasing. However, in some cases, the gap is more prominent. So for example, for Quen 8 billion model, after correction, the score rises higher than for Gemma. And it could also be seen that smaller models like 27 billion parameter Gemma and 8 billion parameter Quen also perform close to higher models. So it also highlights that you don't necessarily need higher parameters as long as you have better architecture or use other techniques to improve your model performance. Among, again, in this lot of numbers, primary thing to focus on can be some rows are entirely darker than the other. Darker is higher score. So for example, true false questions, for most languages performance was high. For NER there is large variation, so named entity representation of models is still not uniform. For math, most of the models are performing poorly. So again, it is not a languages don't affect it as much. Although later we will see for another different pattern for math. And semantically incorrect category marks the gap between English and Indian languages. So for English, it is able to identify semantically incorrect questions more prominently. For Indian languages, that models refuse to do that distinction more often than not. Right? Now, among this, again, higher score is better. Certain things here for math, we will see that the average score that was reported higher was primarily dominated by 2-3 models. Like Quen and GPT-OSS were the models which actually were able to answer math questions. Every other model failed at answering math questions. Now, how does scale matter? We tried for the same architecture model from different parameters, and scale more or less showed uniform increase, which is sort of the expected result. The newer finding is that smaller variants have higher language hallucination. So higher gap between primary score and corrected score. Again, which is somewhat of an expected thing, because smaller parameters means lesser representations for the variance in languages and scripts. Right. So again, more results related to different things. Cross-lingual performance shows consistent degradation between English, Hindi, Gujarati in that order. Odia performing the worst, and some of the models were clearly bad, and some of the models like GPT-OSS and Gemma were clear winners. Now, given all of this, what are the core findings? Core findings are that Indic models do so, like for example, for Indian factored models, models like Krutrim perform slightly better than others. So your training data does affect it. Scale improved the result, but scale does not guarantee robustness to semantic inconsistency. Scale does not guarantee improvement in chronological questions. And in general, this highlights the need for reliable evaluation benchmarks. Reliable evaluation should be multilingual, category aware, not just English and not over random things, because we saw clear demarcation between different performance across different categories. Right. So most of these findings I have already summarized. Some takeaways would be that if you even in as low as 8 billion parameters, you can have relatively high performance, and Krutrim 2 being the model that shines for Indian languages. We also measured questions
Sir,
based on
sorry to interrupt you. We are exceeding the time limit, sir.
Okay. So can I take one more minute? I'll just wrap up.
Yes, sir.
All right. So I'll skip over this again. This just highlights the difficulty of the questions. So most of the questions were more than 4,000 questions where no model answered it correctly. Again, highlighting the importance or the value of the benchmark. Now, some of the other works that we can do are grounding the work in knowledge graphs, using knowledge graphs to answer more reliably, using language models to correct knowledge graphs. So that can be a self-feeding loop. The care, of course, needs to be taken so that your language models are not repairing incorrectly. So that is a category. Can there be cross-lingual transfer? That is another aspect that we have explored, where even if the models are not explicitly trained on language, to what extent can the knowledge be transferred? So in general, the 3 pillars for improving Indian language in NLP is one, of course, LLMs. Other is the linguistic aspect, built using theories rooted in grammar and structured knowledge, which is knowledge graphs. Intersection of these three is the most impactful work for Indian languages. And one benchmark is fine, but the goal is primarily to build reliable systems, culturally grounded systems, and these are the type of problems that we are working on. So thank you, and I can take questions if there are any.
Any questions? Yeah, thank you, Professor Rishikesh. So next, we'll have a quick 5 minutes talk by Sachendra Yadav from BIT School of Design.
Hi, let me quickly share my screen. Uh, can you see my screen?
Yes, sir.
Okay, good. So um, I want to talk about the activities that we are doing on the AI related front and how it impacts design in the design workflow, and how designers can sort of play a larger role in using emerging technologies and AI at a systemic level. So in designing with AI, design can go across the entire design workflow and amplify the work, but as a very targeted and specific UX tasks. These are the techniques that we feel will be radically augmented with AI as it comes along. And these are techniques that we feel will become more valuable as designers shift more towards strategy, storytelling, and cross-disciplinary thinking. So how do you leverage design AI as a design material? So across research, design, defining the product and content, these are some areas where we can bring AI into specific UX tasks to complete just those tasks, and keep the control in the designers or the users level. These are some of the best practices that need to be stringently followed when using AI in the design workflow to make sure that we are aligned with ethical practices, and we are uh, doing things in the right way. Now, one of the challenges that we have as a design school is we don't have ready access to business stakeholders, and we are shifting into the larger roles like, say, business design. So we created this AI agent to simulate business stakeholders so that our students can interact with it in their scenarios that they're working on. The goal is it's an assistant, but it is designed to be it's designed to sort of not give the actual answers. It's designed to provoke thinking. So the learning intent is that how do designers work with uncertainty? How do you work with power bias challenges? How do you coordinate your thoughts under the different stakeholder environments? So it's a learning environment that we've created, for our students, where we couldn't access the direct stakeholders. Next one is integrating AI in service ecosystems. So the students will be trained to critically assess the system at an overall level, and identify where AI can be brought in, targeted in a specific fashion to solve specific challenges. Students will know the strengths and limitations of traditional and generative AI models and other emerging technologies, so that they can have a conversation with the technologist saying, this is the experience that I want. And I think these are the technologies that can enable my experience. Can we have a discussion on, if that's true, if there's something else? To demonstrate this is, a case study. So this is AI-powered healthcare across the entire workflow, how the different AI models can come in the value chain and add value in a very specific and targeted manner to have an end-to-end, end-to-end system level design. This is a project that we're working on. It's for MSMEs. It's in the rural and areas where people have challenges with literacy. This is a voice first AI assistant, and we are working very closely with RBI on this one. This is the business reasoning for this thing. 70% MSME schemes, people think that they haven't been helped. There is a gap in accessing those screens, and how can we bring them, to this unserved audience? The way it works is that the user is asked about what their business is in their natural language, whatever it may be. AI then clarifies, the intent, like are there any gaps? It fills those up with natural language, and then identifies the right schemes, and then shows or talks to the users about those screens. They can take data directly from DigiLocker, or the user can upload any documentation. The forms are filled automatically based on user input, so there's no manual form filling required. And then the application is auto-submitted to different portals. And the RBI is pioneering the ULI network similar to UPI. It's for loans, and so it can be submitted directly through that as well. This one, we are only able to do this is because we have a very tight partnership with the RBI Innovation Hub. They're helping us with the technology, with the details. They're helping us integrate it with the ULI system, and the project has already started. We will probably have something online in about 2 to 3 months. So that's all that I have to add.
Thanks a lot. Do you have any questions for Sachin sir? Thank you, sir. So
Thank
the next event will be a panel discussion. So we have Vatsal. So Vatsal is from 1811 Labs. And then next we have Srinivas Sarkar. So he is also the co-founder of Couple Money. And next we have Divyansh Mangal. He is a co-founder of Ignosis. Sorry if I spelled wrong. So welcome you all. So the topic for today's panel discussion is AI going to replace coders anytime soon?
Hey,
Hello.
hi, Srinivas. Can you hear me?
Yes, I can hear you.
Is Srini and Srini and Divyansh here?
Hello.
Yes. Hi, Vatsal. Hey, Divyansh.
Hi, Srinivas.
Hi, guys. Should we get started, Srinivas? Or
Yeah, you can start.
awesome. Thank you so much. Good to see you here, Srini, and good
Yes.
to meet you here for the first time, Divyansh. Awesome. So, first of all, short introduction. I'm Vatsal Sangvi. I run 1811 Labs. We are an AI venture studio. We've been playing around with generative AI for the last 3 years. We were very early, and we've been experimenting, playing around, and we've seen how things have changed. And when we started off, we were like, "Oh wow, this is gonna change the world." But we also did not anticipate that this is gonna change the world in the way that it has. Right? Super excited to host today's conversation on a question that's been on everyone's mind lately. Will AI replace coders anytime soon? Right? Srini and Divyansh would love a brief introduction, and then maybe we can jump right in. Srini, you wanna go first?
Yeah, absolutely. Hey, firstly, Achal, it's good to see you, or rather to speak to you on call. It's been a while. For the others, Vatsal and I were both in EF about 4 or 5 years back. So this is nice. Good full circle moment. As a quick intro, I'm Srini. I run a company called Couple. Couple is essentially, in the simplest words, it's a joint account that we've designed for the modern couple that wants a quick banking experience and primarily uses our product for shared expenses, which is essentially rent, groceries, your recurring mundane monthly tasks that you do with your partner or with your roommate, right? So that's essentially what we're building. We're not particularly in the AI space. As a big disclaimer, we are where we build something in fintech and in the cross border side. But yeah, happy to share the insights as and when the call goes on.
Awesome. Thanks.
Hi, I'm Divyansh. I'm co-founder of Agnosis. So I graduated BITS like 5 years ago, and since then I've actually delved into quantum computation, did a master's in that, and then came back to AI to healthcare, which is where Agnosis is working in. So we have built a detection tool for autism. So that's a very ignored field, and I felt that the upcoming technology of AI would be best used in something like in healthcare, especially in a field that is ignored, because that's where the maximum delta of change would be. Yeah, and I think we can continue with the discussion then. Srini,
Awesome.
I would like to
Awesome.
have your take on that.
Hey, I'm
Sorry,
sorry, could you repeat the last 5 seconds?
yeah.
Oh, I would love to have your take on what do you think of coders being replaced by AI coders?
Yeah, absolutely. So my take has been, I think one that we've guessed for the longest time, at least in my limited experience, is that AI will make coders more productive. But I think fundamentally, when you look at the early stage startups, right, which is at least from pre-C to Series A, which I'm guessing most of the attendees here are either dabbling in or working in. I think the core objective is always finding PMF, right? And that comes from really understanding edge cases and your consumer extremely well. And I think coders being at the forefront of customer discovery is something that's a very human activity, right? So so fundamentally, an AI can make a coder more productive. It's like having multiple junior coders as well in a small team. But at least at the early stages, this is the first couple of years of starting anything or building anything, right? I still believe that AI will not be replacing the coder, but rather just making the coder significantly more productive.
I would agree and disagree. So the question
Yeah,
itself,
go for it. Yeah.
will AI code replace coders? That's a very binary thinking, with a very 1-0, like, okay, tomorrow 90% coders are gone. That wouldn't happen. It's a very slow slide. But actually, that's an opportunity. So the answer really is yes and no. No, because in my team, I've seen that I only need more coders now, but that's because we want to expand really fast. So each coder's efficiency has gone up drastically. So if they were a 1x, they have gone to be 10x. The real difficulty right now is actually the interface between the human coders and the AI coders. So once the AI code is written, their review is the slowest part right now. So I think that is the interesting space to innovate in and make that interface much stronger. And also, there's a huge opportunity for cybersecurity then. So any cybersecurity folks in the panel, yeah, you guys
Yeah.
have a blast.
No, absolutely. I think I quite agree with that take as well. That it's not binary. I think it also kind of evolves as to what particular tasks are outsourced to the AI as well. But yeah, fair enough.
I sort of have a very different point of view, and maybe that's largely because we are a very, very lean team, and like Srini mentioned, right? We still work very early, and we do a lot of 0 to 1 day in day out, right? I mean, in our team, we've sort of cut down on the number of people in our tech team to only 2 people from 10 people over the last 4 months.
Oh, wow.
We've been maxing out our usage of Claude Code and a bunch of these tools. We've been building out workflows end to end. What our larger understanding has been that, we've sort of figured out a model wherein uh, writing code is not hard anymore. I mean, the way, code is essentially us talking to computers to sort of get them to understand our ideas and workflows or whatever, right? Code is just that. So AI can write syntax, AI can write code, and with agentic tooling in place, right? It is able to do a decent enough job. The only caveat here is that do you have someone who's an expert at orchestrating all of this? Right. A lot of our time right now goes in deciding, what the product looks like or what the feature looks like, and then spending time with our engineers and trying to figure out, what are the functional requirements, non-functional requirements, etc. Uh, and then code is, I mean, the amount of code that AI is writing is possibly 90%, and the rest 10% is our engineers. And finally, of course, like Divyan said, a lot of time goes into reviews. But then again, overall, the process is much, much better. The baseline code for a lot of things in general is much better than what generally humans do. Uh, we've been flabbergasted by what's happening, and we are like extremely excited, and we get supremely excited whenever a new model comes about because we see an opportunity to even ship faster and do much more stuff. But yeah, I mean, that's where we are probably a little different, and I think this probably also changes when the scale changes and a lot of things change, given the impact that it can have on users. But yeah.
Yeah, I think that's kind of been our experience here as well, because by just virtue of us launching newer products, that our engineers just get more productive, especially when we have a smaller team as well. I think your ramping down from 10 to 2 is, I mean, I have to take some notes probably offline, but yeah, like I fully agree.
Yeah.
Off the record, but yeah. Hmm.
No, I agree as well. But I haven't seen the ramp down. I've seen more of keeping the same team and expanding the products and services that we are giving out. So I think same stuff, like anyway, you're expanding exponential number of features per day. So it's just the iteration rate has gone up. But I think it's like as you mentioned, the coders now have to shift their roles from actually typing out the code to being architects and product managers for the AI coders. So it's a fundamental shift in how CS as a branch is shifting. But I don't see that in education right now. When I still interview people, it's very DSA minded kind of guys, but I don't know how to deal with that. Like I think that is where the signal to education institutions should go, that it's not even model building. It's really about becoming architects and product managers for AI coders, for AI codes. So that's what I think the world is in the computer science is going, especially.
Since you've been hiring, right? I mean, we've sort of cut down on junior hiring a lot, given how it's all gone about, right? How's been the case for you? Uh, how do you look at it?
Uh, yeah, so I would actually completely agree with that. I only hire at a certain level, especially those who have shown efficacy, showing they can work with AI as a tool rather than opposing it. There's still a lot of lag in how students, very young, final yearites coming out, who haven't really used it to build product. They've just used it to chat GPT codes, and that's not a good integration system for us. I still look for people who have worked with AI and are 10x engineers because of that.
Right. Srini, how's been the hiring scene for you? How are you looking at talent right now, especially in engineering?
Yeah, for us, for the longest time, we've actually hired junior folks who've been fresh out of college, and they kind of grown from there with us over the last 3 years. But I think, and this is the question I actually had for the both of you as well, that going forward, is the approach to therefore hire mid-level engineers who can then orchestrate, as you said, Vatsal, all the tools and resources that you have, and not to therefore hire on the earlier side or on the fresher side. Is that something that you guys have seen with your peer groups as well?
Yeah. I mean, I, for me right now at this, so first of all, right, what I think about the space in general is that what is true today might not be true tomorrow. Because the way things are changing, there are no like frameworks or playbooks that are established right now, and everything is being rewritten, right? In terms of building out engineering teams or hiring coders per se, what I think has happened that the younger talent right now lacks a lot of fundamentals, and they have sort of skipped the part wherein there's a lot of grinding which goes into writing code by hand, etc. Because of which you do understand a lot of fundamentals, and because Chat GPT or whatever model that they've been using, Claude, whatever, right? A lot of these younger folks lack that talent, right? and AI is like extremely good at doing the repetitive stuff and writing the baseline code, etc. Right? So for it's very clear, right? If we want someone who's who's orchestrating systems, we'll hire someone who's good at that. If we want someone who's good at mobile apps, we'll hire someone for that. And then we would get in contractors for, let's say, something like DevOps, etc., and get AI to do the heavy lifting. So for us, it's essentially like there's someone who understands the code, like Divyansh mentioned, right? 10x engineers, someone who understands how to write code, but also understands how to augment these workflows well enough, etc. Is the kind of talent that we are looking at. And the second layer, I think possibly as we grow and as we might want to hire people just so that the human in the loop process does not get broken, backups, etc., or more projects, right? Even if there are younger folks, right? Strong fundamentals and strong orchestration skills are extremely important. Uh, Other than that, I think those days are gone wherein, would hire 5, 6, 7 interns, get a lot of front end done, get a lot of internal tooling done. All of that is definitely being replaced.
Yeah, I've actually seen this cross-functionally as well, even across marketing, for example. Like, folks who started their careers maybe about 6 years back have gone through the grind and actually, know a lot more about the fundamentals than folks who probably started. And it's of no fault of theirs really, but those who started maybe about 2 to 3 years back, and that's totally reflective on coding as well. Absolutely.
Yeah, I mean, on the cross-functional bit, right? It's been the case. I mean, will AI replace coders? Arguable, yes. I don't know, but it's definitely replacing a lot of ops people for us. We're automating a lot of data scraping, data monitoring, MIS-related processes in-house. I mean, getting tools built, getting agents built, spinning off workflows while coding these out. That's definitely happening for sure.
Yeah, I think I agree on both points, cross-functionally and on vibe coding. But then I get a lot of calls from my juniors who are just graduating or are worried that they're in final year, what to do next, or in first year they're getting to the colleges and they're like, what branch should I take? And I kind of worry about saying that you should take computer science now. Like, for productivity wise, obviously it makes sense to get uh, the middle-aged person who has the fundamentals right. But then what about those children, like those coming out, younger folks coming out? And for them, I think the answer that I've figured out is actually just build stuff. Like, don't care about getting a job per se, but build stuff and build like strategically important code that traditionally we have been reliant on foreign parties. For example, simulation softwares. So those are all US based, and now given the geopolitics, I think it's a good time to move fast on those kind of strategic infrastructure level codes and build startups out of that. And that's actually a good opportunity for younger folks to build their own systems in very small teams, which might require much less funding but can give a much bigger impact. So, uh, per se, AI will not replace coders. AI will make more entrepreneurs.
Yeah. I mean, maybe I'm still trying to sort of gather my thoughts around or wrap my head around how uh, someone who's just joining in the first year should think about this, because what we know today will change drastically by the time they sort of get to their second year, third year, fourth year, and uh, I'm not sure if learning can keep up with what's happening. But I do definitely think that anyone who has like very strong fundamentals and has an equal exposure to building out high quality projects, not just doing, the basic stuff that would allow you to sail through for the longest time, but building out deeper stuff, understanding a lot more nuance to going depth. I mean, anyone who has depth in software engineering, coding, or any of these systems per se would definitely continue to thrive. Experts or specialists will continue to thrive, and so would hyper generalists, right? So probably a good way for anyone to approach computer science or any of this would essentially be either you go very deep into one thing that you're really passionate about, get the fundamentals in place, but keep on doing projects. And if you were supposed to do, let's say, one project in the past era, and right now you're supposed to do 10 projects, 15 projects. I don't because AI can help you do things very, very quickly. And second, if not, right, play around with a lot of stuff, understand how all of these systems interact with one another, what are the nuances, have the ability to orchestrate various stacks, various workflows, etc. And whenever you're stuck, try to understand the deep fundamental behind it. If all of that sort of goes through well enough, I don't think there's a problem. But anyone else who's just sailing through because there were a lot of jobs, or just because they knew something, that alpha does not exist anymore, I think.
But Vatsal, do you see that catch-22 here for a person in this situation? Somebody starting out needs to be in contact with experts, with those experienced in the fundamentals, kind of get a job or an intern under them, and then build their own niche around that area. But then now that people are not getting that kind of jobs initially, or it's really hard to get by, how do they become that specialist that you're talking about? Like, I do wonder for even my cousins, like, who ask me what to do next.
Yeah, no, absolutely. I think again, there's definitely a catch-22 here, but you know, the information asymmetry does not exist anymore. That having access to a specialist is no longer a problem because LLMs have all the knowledge in the world. If in case they're stuck with what to do, etc. Now, having access to real-world projects, it's definitely and because those projects come with a lot of guidance from people who have done it over and over and who understand the nuance, that's definitely a problem. But then again, the open source world has probably expanded to great levels today. If you're stuck anywhere, right, being able to use the LLMs to understand what's the best way forward is a great option. But then again, you have to be enterprising enough to sort of break this barrier and sail through. Again, it's probably not as easy, but at the same time, it's very exciting to be able to do everything uh, without actually, having to wait for someone and things like that.
I've actually also found that it's the opposite as well. Like, the younger folks are pretty open with all the systems, and they can learn much faster, pick them up, because it's so fast. Honestly, it's hard to catch up. And the older folks who have the experience in the field but are not so open to the new tools, they have actually sometimes hard time figuring out what to do. So, what's your take on that? Like, in some sense, they are good at orchestrating, but they might be bad at taking up the tools. So I've also found that out, and has been my experience with some of my employers.
No, absolutely. I mean, I mean, probably these are the times wherein learning and unlearning are very, very important for anyone. Anyone who has like rock solid fundamentals has to understand that, okay, these are there, but then again, I might have to learn and unlearn over and over again. What I know today might not be relevant in 3 months, or what I'm doing right now might substantially change. And that is why younger folks who are enterprising would succeed. And that is where people who are very stringent in what they do and how they do things will face a lot more issues. And that is where I think that unlearning, learning, unlearning, that's those cycles. I mean, we're still very early. These are still very nascent days, and we probably might see a very different world in the next couple of years, or in the time to come, right? So, going through this phase while the baseline gets shifted will be a little uncomfortable for a lot of people, and then maybe when everything gets settled down, or if everything gets settled down, we will
Nothing is
probably understand how probably to approach all of this.
agreed.
Yeah, I think any contra opinions, Srini or Devansh, on or any of this which is happening right now, especially when it comes to AI and coding?
I mean, a lot of people. So the discussion has been here, especially from a perspective of a student who might be listening. Is that it's all doom and gloom? But I think it's a huge opportunity. So there's a very different perspective to look at it, that you don't have to be bogged down by boilerplate codes. You can just move at breakneck speed with a ragtag bunch of excited people who know how to use, who are willing to learn and are learning to use these incredible tools. So I would rather implore anyone who's listening who wants to build something to be like really, really ambitious, because nobody in the world knows what's going on. Everyone is, for everyone, these are like incredulous technology coming up. So, rather than this panel discussing it like a doom and gloom for new folks coming up to the industry, see it as opportunities. Yeah, flip the perspective on this.
Yeah, Srini, any thoughts on that?
No, I fully agree. I think one of the points mentioned a while back was that the catch-22 situation on just accruing expertise, right? I think like Divyansh said, I think just building stuff when you're in college on your own, as much as you can, getting your hands dirty. I think that seems to be the best way to do it. So you're already kind of ahead of the curve before you're in the job market, right? So I think that's something that I would urge everyone to do. I'm sure all of us as founders, we all feel we're a little late to the game. I don't know when Divyan started, but I know that for Vatsal and I, like we were in our mid-20s. So if one could go back and learn and build much early on, we would do that. And especially now, given how tough it is to just organically accrue experience and expertise in honestly any field, especially coding.
Same
No, I
mid-20s.
absolutely agree.
Yeah.
Yeah,
Mid-20s.
of course, Srini is much older, but I do agree. But I do agree that I'd really want to be back in college, or maybe be a little more younger, spend like 20 hours building stuff. Given how exciting the times have been, and like Bipyan said, flip the switch, no matter who you are. I mean, a student or a founder or a builder. uh, when no one knows what's happening, it's a great time to be alive, because even a 0.1% delta will look like an incredible delta over others.
Yeah, it's a non-linear system, and like even the smallest starting differences would be massive in years later. Yeah, classic non-linear evolution of a system.
Yeah. I think maybe we are about at time. We had 30 minutes for this, but any last closing thought, Divyan, Srini, before we close off the discussion?
I think now that coding is much easier to approach, even for those who haven't, and treat the AI code as more like a smart coder and your friend who is non-judgmentally teaching you a lot. Really, really built for problems. Like in the last year that I've built the company, that's what we have done. Like just focused on the problem itself, and the rest all sorts itself. Even the money comes through. That's what I found. Yeah. So please just focus on real world problems. That's even in India context, like we have very specific problems at the scale that we operate. So if you just build that, that's great. Like I'm really just imploring people to use these new fantastical tools to build really fast, really well, and very specifically.
Awesome. Srini, closing thoughts?
Yeah,
Should
actually
couples
bang
learn
on the
how to
same.
code
This is
together?
yeah. No, but I think exactly the same piece, right? That is especially now when you're able to, like, I think the mistakes that we made were also working on things that we weren't sure were real problems, not talking to consumers, and then like having to pivot very slowly. But I think today you could one is try to solve a real problem, and if it's not working, build something else very quickly, right? So that gets you both to understand exactly what to build, and you can do that much quicker as well, given all the AI tools that are at your disposal. So yeah, like would urge everybody who's in their early 20s or in college to build a lot, because it's the best time to do that, and build not just good ideas, quote unquote, but like solve actual problems, and there are too many of them out there anyway. So yeah, my closing thoughts.
Awesome. Thank you so much. I think happy that we are probably closing this with a lot more hope than a lot more doom that we started off this session with. But yeah, thank you, folks.
Yeah, thanks.
Srinivas, do you want us to take questions or should we close this
Yeah,
session?
we'll ask briefly, like, do you have any questions?
There is one in the chat.
Yeah, I can see it.
Yeah.
Hello, panel. Devanshi, do you guys want to take a shot at it? Or
Honestly, do both. If your fundamentals are not strong, you wouldn't be able to catch up if any fundamental breakthroughs happening. And if you're not building on the product side, then you don't know how to build. So you really have to divide your time between both. That's what I do as well. My research team looks at research, and then actually the tech team builds it out. And both discussions are very informative for me.
yeah, I mean,
I
with
think
the kind of orchestration and augmentation AI can do for you, you're not possibly be gonna write 1,000 lines of code any which way. So you still have a lot more time in building your fundamentals at the same time and building things out while understanding what's happening. So I mean, in the past era, doing both of these things would take a lot more effort, but now it won't. So I mean, you will have to figure out how does that work out for you. What's the learning play for you? Then again, you just can't do one and survive right now.
Right.
can I add
And
something as well? Just
pardon?
the last point on this. They speak about placements as well. I think rather than focusing on placements and doing fundamentals because of it and because you require grades, look at it more like abilities to think, because that is really your differentiator nowadays. I haven't really ever looked at grades while hiring someone, but I really do ask questions if they understand the fundamentals. So do it for that, and then show some cool projects, and that would probably get your placements sorted.
Right.
Yeah. Thanks a lot,
Awesome.
both
Thank you, Anirudh.
Srinivas and Divyansh. So just to give a brief, like, is AI going to replace coder anytime soon? I think it is no, because when the ATM came, many people thought a lot of bank branches will be closed, but in turn it increased a lot. Even when the computers came, many people thought a lot of accountants' job will be lost, but in turn it increased a lot. So AI will just help to work efficiently and like a kind of, like, it will help us to develop the application very quickly. So this is my viewpoint.
Awesome. Truly exciting times for us to figure out. But yeah, thank you so much.
Thank you.
Good chat. Cheers.
Yeah, and the next talk will be by Mr. Arvind from Bitsom.
Srini, can you hear me?
Yes, sir.
Fantastic. All right, let me share my screen quickly. I have only 5 minutes, so I have only a few slides. I don't have a lot of slides. Srini, are you able to see my slide?
Yes, sir.
Fantastic. All right. My name is Arvind Ravishankar. I am working with the BIT School of Management. I'm actually based in Silicon Valley. I've been in the US for the last 20 years or so. I have a master's in engineering and an MBA from UC Berkeley. And I've been working in the field of strategy and consulting, management consulting, for over a decade now. My last role, I was at Wipro. I was heading Wipro's AI innovation programs in Silicon Valley. I was reporting to the CTO, and I built out Wipro's generative AI accelerator, their research think tank, and also their incubator. And that's how I got connected with Bitsom. I'm no more with Wipro. I run an independent AI innovation studio in Silicon Valley, and I'm now traveling to India to help Bitsom build out a Y Combinator for India. And the vision for this program is to graduate 100 global scale AI startups in the next 3 years. This is an exclusive AI incubator. And the reason we say global scale is, going back to the talk, actually, it's interesting that I got queued up after this panel. There are to give us statistics and numbers, there are 5 million software engineers in India. And interestingly, 80% of the software engineers in India have work experience less than 5 years. So if coding, it could be that coding is, like you said, Srinivas, it could be an ATM or a calculator, or because we are now in the frontiers of intelligence, while in the past we were in the frontiers of machines, now we are in the frontiers of intelligence. There could be a scenario where coders could get replaced. And if that does happen, a major part of India's economy is going to be in trouble. Now, the second part is, even though India has 5 million software engineers, the second largest in the world, India has maybe one or two software products that cater to the global market. Majority of the software products in India either cater to the domestic market, or majority of them were copied or are fast innovations from other companies in other countries. And this is the reality, right? And I don't mean to offend anyone here. I grew up in India and I have a deep passion for India. But the reality is that India has never shipped software products that cater to a global market, even though we've been building software products for over 40 years now. I think it's, with AI, there's an opportunity to change that equation. And I think there's an opportunity to bring India to the global market. And the goal of this accelerator or incubator is to provide startups with everything they need for them to be successful in a global scale. That is the number one goal. Um, the the second goal of the accelerator, and this is the reason why Bitsom is so passionate and Dean Saravanan is so passionate about this, is because, again, in the panel we heard that experiential education is almost more important today than theoretical education. So we want BITS management students, when they graduate, we want them to have immersive knowledge in artificial intelligence technology, not just theoretical knowledge, because I strongly believe that business school students or anybody who's graduating needs to understand how to build AI products. Because, in one way, you can argue that coders are going to get disrupted, but another perspective is that the entire world is going to become coders, because in a few years, or maybe in less than a decade, you're going to tell the computer what you want and you're going to get that in the form of code. And so, to some degree, you can also argue that everybody is going to become a coder, right? So, at least for the next 5-10 years, we want every business school graduate to have that immersive learning, and Bitsom should become the number one business school in the country or maybe even the world for AI graduates. And this accelerator will allow these students to participate in a real world environment and learn how to build AI. Now, the students themselves will not. They are not going to be the founders. This is an industry incubator slash accelerator similar to Y Combinator, and the students get opportunities to apply for credits similar to a course and be part of a startup and watch the startup build and participate along with the startup to build out that particular accelerator for course credits for a few months. Now, the model, we're going with a differentiated model where Bitsom is the one funding the program, but we also have a partnership with Silicon Valley through my innovation studio lens. I'm going to bring in the Silicon Valley angle into the accelerator. I'm already putting together an enterprise leadership council with a bunch of Silicon Valley leaders who would become board advisors for this accelerator. We're also bringing in all the hyperscaler partners. We already have credits established.
Sorry, sir.
Yeah,
Sorry
good.
to interrupt you, sir. Like, we are having a shortage of time.
Got it. Okay, I need another minute to complete.
Okay.
Um, And finally, the unique part of this accelerator is every startup is going to be paired with a corporate customer from day one. So, this is how we're going to start getting to that global scale by building with a customer from day one. And so that's the reason why this incubator is much different from most other incubators, where you're going to get terrific resources, but also build with customers from day one. I'm happy to talk more about it. Software automation, multilingual AI, vertical AI, enterprise AI, these are all going to be really important tracks that we will focus on. And we're going to kick this off, launch the program in April, and the first cohort of startups will kick off July through September. I've provided my LinkedIn here. If you scan the QR code on screen, you will be able to connect with me. Or if you take a picture, you can send me an email at my Bitsom ID. I am very much interested in talking to all the different people today who presented, because there's so much amazing work going on in AI. And if there's a way in which you can help us or participate in this incubator, I would be completely open to it. And since we are in this foundational building stages, this is the right time to reach out to me or to Dean Saranan so that you can talk to us about it. But we're quite excited and hope this brings a lot of value both to BITS ecosystem and also India, putting India on a global map, right? That's the goal here. So thanks everybody for the opportunity, and Srinivas, Varun, and the rest of the team, thank you for the opportunity for me to present.
Thank you, sir. Is there any questions? Thank you. We'll go with the next talk by Professor Sri Parana Saha.
Yeah. Is my screen visible?
Yes, ma'am.
Yeah. So first of all, thank you very much, Snehangshu and Amitabu, for giving me this opportunity to talk in front of you. So today I'm going to present some of our research initiatives that we have started in the last 1 or 2 years. So building some benchmarks and models. So the motivation is to make some inclusive AI systems for the Indian languages. So the motivation is very simple, that that in the generative AI models we want to make the inclusive. Basically, we want to make some inclusive AI systems, because these current AI tools are mostly English centric and resource imbalance, and there are many biasness studies that have been done in the recent past, and there is a lack of data sets and cultural grounding and the multimodal resources. So towards this direction, my team has developed some multimodal resources focusing on the Indian context. And we have found that benchmarks are the foundation for model building. So let me briefly discuss our contributions in building the benchmarking. So in the cultural aspect, like focusing on the Indian culture, we developed a Sanskriti dataset. So this is a question answering dataset covering fine-grained Indian cultural artifacts, covering all the Indian states and the union territories. So there are around 21,000 question answer pairs. So I will discuss about this in detail. Then its multimodal version is called the Drishtikon. So here we have not only introduced the multimodality, because now this is a kind of visual question answering system. And again, all the Indian states and Indian territories are present. But also it is multilingual, because we have translated the questions into various Indian languages. And then focusing on the local sports, in India and also many of the countries, there are many local sports. So we really need to understand whether the LLMs have the knowledge of this local sports or not. In order to test that, we build a benchmarking covering many 60 such local sports, and that is also in the multilingual setting. So this is called the cultural sports question answering dataset. We also work in the multimodal summarization. Multimodal summarization is a very traditional task of natural language processing, where you are giving a document, you need to generate a summary of the document. So in the multimodal summarization, you will be given some text, images, and video, and you need to generate in the output also some multimodal output, like there will be a text summary, in image summary, and the video summary. So there was, when we started this research in the years 2020, there was no Indian multimodal summarization data set. So my students have basically curated this data set called the M3LS from BBC. So this is the first of its kind in the Indian context, multilingual, multimodal summarization benchmark. And then nowadays, one problem statement is becoming very emerging, which is called the reader's comment aware multimodal summarization. Like suppose there is a BBC article or the CNN article, you know, now the reporter wants that the reader should also, write some comments regarding the article, because sometimes the reporter is biased towards a particular political party, or maybe the reporter has made some mistake while writing the report. So that's why they also used to invite the readers in writing some comments. So can we incorporate the reader's comment into account while generating the summary? So this is called the reader's comment aware multimodal summarization. So again, we created a Indian data set which is multimodal in nature, and also there are comments and documents and also images. So this is just our last year ACL paper, Cosmic. So in the information retrieval domain, we created some multilingual, multimodal retrieval system focusing on the healthcare, domain particularly. So there are images, image query, and also some textual query, and you can easily retrieve some case studies or the summarization. So this is particularly focusing on the healthcare domain. And regarding the model development, we also created a small language model focusing on the animal sciences, because when we started this research 1 year back, there was no, most of the LLMs were not giving good result for the animal science related queries. So we felt the necessity of developing a small language model for the animal sciences. So we named this at the VET LLM. And also we did some robustness studies of the medical LLMs in the healthcare domain, especially in the multilingual setting. So so I know the time is very limited. So let me quickly discuss about how we curated this Sanskrit data set. So this is our last year ACL paper. So basically, we collected data from all the tourism web pages and also all the Wikipedia pages. And this data set is very exhaustive in nature. There are 21,000 question answer pairs covering 21 all the states and the union territories. And we cover all the fine-grained aspects of the culture. Like there are all the topics, the history, rituals and ceremonies, cuisine, costume, all the fine-grained aspects we are able to cover. And then we curated this question answer data set. And as you can see that mostly all the states are covered. For few states, maybe online resources are limited. That's why question answers are also limited. For example, from Jammu and Kashmir, representations are less. So then we tested many LLMs and SLMs and also some Indian LLMs on this data set. And our observation states that for some aspect like religion, medicine, and cultural common sense, somehow language models are doing really good. But for attributes like costumes, cuisines, and art, these language models are really struggling. And especially for the northeastern states, because the resources are very less available in the online. So that's why maybe these language models are not trained with enough data regarding the northeastern states. So the language models are really struggling in answering the questions related to the northeastern states. And similar performance, similarly for Bihar and Jharkhand also, language models are not good in answering the questions related to Bihar and Jharkhand. But for Delhi and Maharashtra, they are doing quite well. So regarding the Dishtikon, so we made the dataset multimodal. As I mentioned that this is a visual question answering system, and also it translated the dataset into various languages. Like there are 15 languages in which initially the question answering was in English, but then we translated into 15 other Indian languages. So we have covered all these 15 languages and many fine-grained aspects of the culture. And again, we tested many visual language models. And similar kind of observations we like the results suggest that for Kerala, Gujarat, West Bengal, models are showing good performance. But for the regions like Lakshadweep, Mizoram, Dadra, Nagar Haveli, somehow there is a low accuracies. Similarly, for the languages like English, Hindi, Bengali, and Marathi, models perform really well. But when we are talking about the languages like Konkani, Kannada, Assamese, and Odia, there is a accuracy drop. So these are some of the observations after doing some ablation studies. So regarding this local sports, you know, that we need to, this is an international project that we have done with many collaborators from many of the countries, because this is not only in Indian context, but also in the international context, because there are many international languages are also attached to this project. So we collected data from various continents, from India, from you know, Asian, many from Thailand, from Africa, and also many of the European countries are also there. And we translated data set in various languages as well. And there are many annotators who are also involved in this particular project. There are 11 languages and 80 local sports. And you know, there are 4 types of questions in our data set. Sometimes we are asking the history regarding the local sports. There are some scenario-based questions, some rule-based questions, and sometimes we are showing an image, and then we are asking the question related to the image. And then questions are translated into many of these 11 languages. There are total 33,000 question answer pairs in this data set. We tested many of the LLMs and the VLMs for this data set. And regarding this multimodal summarization, as I mentioned, that this is our 2 years back in ESCL, we released this data set, and this was the first of its kind multilingual multimodal summarization data set. We collected this data set from BBC, and you know, BBC news looks like this. There is a title, there are some images, and there is a body, and also there is a reporter generated summary. So we basically crawl this kind of data, and there are 20 languages, not only some Indian languages, but also some other languages are also present in our data set. And then we did this is mostly data set paper, but we did some, ablation studies, like we applied many basic algorithms like random, lead3, test rank, centroid. These are some basic algorithms that we applied on this data set. And like what I mentioned, that recently we released this data set, which is called the Cosmic, which is the readers comment aware multimodal multilingual data set. So where we have, like you can see from this particular slide, that we are having a news article and also some images, and also readers are now commenting on the news article. So, all the comments are not useful. Some comments are noisy in nature. So, there is a task also that you need to categorize the comments into multiple categories, because some comments are giving you some supplementary information. Some comments are giving you some, complementary information, and some comments are simply noisy comments. So before adding the comments with the documents, you need to categorize the comments into these 3 categories, and then only maybe you can add the comments with the document, and you can pass through some summarization module to get the summary. So this was the task. And as I mentioned, there was no dataset available in the Indian context. So this is the Cosmic dataset, where there are 9 languages present, and there are 4,959 image article pairs. And I need to stop. So there are 24,000 readers' comments. And these are some of the ablation studies that we have done. We have done with only article, then article plus comments, article plus related comments, like we have discarded the noisy comments, and article plus images, then article plus images plus all comments. And when we are only considering the related comments, like when we are discarding the noisy comments. So somehow in this Indian context, comments are not playing an important role. So our ablation studies established that here, in somehow the article plus image, this setting is only giving us the better result. Somehow comments are simply adding noise. Okay. So so we are investigating more into this, like how we can how the comments can be helpful. So now the work is going on. So yeah, like I think let me conclude. So yeah, so these are some of the works that we are doing in our lab in IIT Patna. We have a research team called AI NLP ML, and our main vision is to develop some inclusive, multilingual, multimodal AI systems. And yeah, so I would like to thank my research team and all my sponsors for supporting my research. And again, thank you very much, Nihangshu and Amitabh, for giving me this opportunity.
Thank you, ma'am. Is there any questions? So I would like to request Professor Snehanshu Saha to conclude the event.
Yep. Yeah, thanks, Riparna. I know it was last minute, and similarly, thanks to all the speakers whom we reached out to very last minute, because we kind of had to plan in a hurry. Thanks to all my colleagues from all Indian campuses for joining me and helping me, and Srinivas to organize this. See, the idea behind doing this, short webinar was, one, to showcase what we are doing, and two, to observe if there are some trends of research work in collaboration either with industry or other academic colleagues that could come out, which pits us as a strong contender in terms of a knowledge partner in the overall India AI mission, right? I mean, thankfully enough, I mean, while taking nothing away from the text-based processing and the advances that GPT models have made, in the last 6 months especially, right? There are, still classical unsolved problems that need to be addressed. And in the policymaker circles, in the meetings with some of the Bharat AI and India AI mission policymakers, I think it has started resonating that we need better control over our predictive models, which Professor Jan LeCun and Professor Joshua Bengio both have been advocating recently, right? So what can BITS Pilani do? I mean, as part of being aligned to the India AI mission in general, not only for a particular event, but maybe over the course of next couple of years, is to be able to contribute both in terms of LLM research, also a mixture of vision language models, as well as a lot of applied manufacturing problems that we can take a crack at, and also some of the fundamental problems which are unsolved, like what Professor Aditya has mentioned. With this, I would like to conclude, and I'm not participating in the India AI mission as I'll be traveling to another event, but some of my colleagues will be participating. So if you are also present at the India AI mission, please stop by our pavilion, and we can chat and discuss further possible collaborations. Thank you very much for all for joining in, and once again, thanks to all my colleagues for helping me organize this. With this, let us conclude. Thank you.